Right now, while you're watching this, something extraordinary is unfolding in our solar system that has astronomers around the world scrambling to their telescopes. What started as routine observations of a single interstellar visitor has evolved into something far more complex and, frankly, more unsettling than anyone anticipated. 3. I-Atlas, our mysterious wanderer from another star system, was supposed to be a straightforward story. An ancient comet carrying secrets from distant worlds, following a predictable path through our cosmic neighborhood. But as this interstellar interloper approaches Mars in the coming weeks, we're witnessing something that defies explanation. New objects are appearing seemingly out of nowhere, clustering around 3I-Atlas's trajectory in patterns that challenge our understanding of celestial mechanics. The numbers don't lie, and they're telling us a story that makes seasoned astronomers question everything they thought they knew about how our solar system works. What we initially dismissed as cosmic coincidence has transformed into a phenomenon that's forcing us to rewrite the rules of interstellar physics. Tonight, we're diving deep into the mystery that has the scientific community on edge and asking the question that nobody wants to voice out loud. What exactly is 3I-Atlas doing to our solar system? But before we unpack this cosmic puzzle, let me show you why this matters more than any astronomical discovery in recent memory. This isn't just about one unusual object anymore. We're potentially witnessing the first documented case of an interstellar visitor fundamentally altering the dynamics of our local space environment in real time. The story begins where most great mysteries do, with something that seemed perfectly normal until it absolutely wasn't. When 3I-Atlas was first detected by the Atlas Survey Telescope in Chile back in July, it appeared to be exactly what astronomers expected from an interstellar comet. Ancient, exotic, but ultimately predictable. A wandering chunk of ice and rock that had been drifting through the galaxy for potentially billions of years before stumbling into our solar system. The initial observations painted a picture of cosmic business as usual. 3I-Atlas displayed the classic signatures of a comet awakening under solar heating, a growing coma of gas and dust, a developing tail structure, and spectroscopic signatures that confirmed its interstellar origins through chemical compositions, unlike anything found in our local cosmic neighborhood. Everything about it screamed natural phenomenon, albeit one with some unusual properties that made it scientifically fascinating. The object's trajectory seemed straightforward enough. Racing inward from the outer solar system at tremendous velocity, 3I-Atlas was scheduled to reach perihelion in late October before swinging back outward and eventually departing our solar system forever. Its path would carry it relatively close to Mars in early October, providing telescopes with an excellent opportunity to study this interstellar visitor in detail. But as summer turned to autumn and 3I-Atlas continued its approach, something began to change. The first hints appeared in routine sky surveys conducted by observatories worldwide. Objects that shouldn't exist started showing up in the data. Small, fast-moving points of light following trajectories that seem somehow connected to our interstellar visitor's path through space. Initially, astronomers dismissed these detections as observational artifacts or previously unknown members of our solar system's asteroid population. Enhanced survey capabilities from facilities like the newly operational Vera Rubin Observatory were discovering new objects at unprecedented rates, so a few extra asteroids seemed unremarkable. But as the catalogue of new detections grew throughout August and September, patterns began to emerge that couldn't be explained by improved observational technology alone. The clustering was subtle at first, visible only to researchers analyzing the statistical distributions of newly discovered objects. But by early September, the pattern had become impossible to ignore. Dozens of small objects were following trajectories that seemed to converge on the same general region of space that 3I-Atlas would occupy during its Mars flyby. The probability of such clustering occurring by random chance was vanishingly small. Yet there it was, clearly visible in the observational data. Dr. Elena Rodriguez at the European Southern Observatory was among the first to recognize the significance of what they were seeing. Her team had been conducting follow-up observations of 3I Atlas when they noticed something peculiar about the background star field. Objects that should have been stationary relative to the distant stars were showing subtle but measurable motion. Not the smooth, predictable motion of known asteroids or comets, but erratic changes in position that suggested something was influencing their trajectories. The breakthrough came when Rodriguez's team correlated their observations with data from other observatories worldwide. What looked like random noise in individual datasets revealed itself as a coherent pattern when viewed from multiple perspectives. The newly detected objects weren't just clustering randomly around 3I Atlas's path. They were actively converging on the interstellar visitor's trajectory, as if drawn by some invisible force. This discovery triggered an immediate surge of interest from the global astronomical community. Telescopes that had been dedicated to other research programs were suddenly redirected toward tracking these mysterious objects. The European Space Agency's Gaia spacecraft, originally designed to map stellar positions with unprecedented precision, began detecting dozens of additional objects in the same region of space. Ground-based radar systems joined the effort, bouncing signals off the new objects to determine their sizes, compositions, and exact trajectories. What emerged from this coordinated observation campaign was a picture that defied conventional explanation. The objects clustering around 3I Atlas's path weren't typical asteroids or comet fragments. Their radar signatures suggested compositions and structures unlike anything in the standard asteroid taxonomy. Some appeared to be predominantly metallic. Others showed signs of complex internal structures that scattered radio waves in unexpected patterns. More puzzling still was their behavior. Traditional celestial mechanics predicts that small objects in the solar system should follow stable, predictable orbits determined by the gravitational influences of the sun and planets. But these new objects displayed trajectory modifications that couldn't be explained by gravitational forces alone. They were accelerating, decelerating, and changing direction in ways that suggested active maneuvering or response to external influences. The timing correlation with 3I Atlas became impossible to dismiss. As the interstellar visitor approached its closest point to Mars, scheduled for early October, the clustering of mysterious objects intensified. New detections were being reported daily, sometimes hourly, as survey telescopes captured more objects joining what was beginning to look like a cosmic parade converging on the red planet. Dr. James Chen at MIT's Haystack Radio Observatory proposed what would become known as the shepherding hypothesis. Perhaps 3I Atlas, despite its modest size, was somehow influencing the trajectories of smaller objects through mechanisms not accounted for in standard gravitational models. The interstellar visitor might be carrying exotic materials or generating fields that could affect nearby objects in ways that conventional physics hadn't anticipated. This theory gained support from detailed analysis of 3I Atlas's own unusual properties. The object's extreme carbon dioxide dominance and unusual metallic signatures suggested formation conditions unlike anything in our solar system. If it had formed around a different type of star or in a stellar environment with unusual properties, it might possess characteristics that could influence other objects in unexpected ways. But the shepherding hypothesis faced significant challenges from basic physics. Even if 3I Atlas were made entirely of the densest materials known, its gravitational influence at the distances involved would be negligible compared to the much larger gravitational fields of Mars and the Sun. Any exotic fields or forces strong enough to affect multiple objects across millions of kilometers would likely be detectable by our most sensitive instruments, yet no such emissions had been observed. Alternative explanations began to emerge as more data accumulated. Perhaps the clustering wasn't caused by 3I Atlas directly, but represented the remnants of some larger object that had fragmented during its journey through interstellar space. If the original body had broken apart millions of years ago, the resulting debris cloud might be spread across a considerable volume of space, with different fragments arriving at our solar system at staggered intervals. This fragmentation scenario could explain both the clustering pattern and the unusual properties of the newly detected objects. Fragments from a single parent body would naturally follow similar trajectories through space, while potentially displaying the exotic compositions and structures that made them so difficult to classify using standard asteroid taxonomy. However, the fragmentation hypothesis struggled to account for the apparent coordination in the object's movements. True debris fragments would follow ballistic trajectories determined entirely by their initial velocities and the gravitational fields they encountered. The active maneuvering observed in many of the clustering objects suggested something more complex than simple fragmentation physics. As October approached and 3I Atlas prepared for its close encounter with Mars, the scientific community found itself grappling with observations that challenged fundamental assumptions about how interstellar objects should behave. The phenomenon was unprecedented in the short history of interstellar visitor studies, raising questions that extended far beyond the specific case of 3I Atlas itself. Were we witnessing the first documented example of interstellar debris cloud dynamics? Had we stumbled across evidence of exotic physics operating in interstellar space? Or were we simply observing the statistical endpoint of natural processes that we hadn't previously had the observational capability to detect? The answers to these questions would have to wait for the crucial observations planned during 3I Atlas's Mars flyby. As the interstellar visitor approached within 29 million kilometers of the red planet, telescopes both on Earth and in space would have their best opportunity to study not just 3I Atlas itself, but the entire population of mysterious objects that seemed to be following in its wake. The implications of what astronomers were observing around 3I Atlas began to crystallize as October's crucial observation window approached. What had started as statistical curiosities in survey data was rapidly evolving into something that demanded immediate attention from every major observatory on Earth. The sheer volume of new objects clustering around the interstellar visitor's trajectory was straining the capacity of global tracking networks designed to monitor our solar system's normal population of asteroids and comets. By late September, the catalogue of mysterious objects had swelled to over 200 confirmed detections, with dozens more being added each day. Each new discovery seemed to deepen rather than resolve the growing puzzle. The objects displayed such diverse characteristics that they appeared to represent an entirely new class of solar system inhabitants, one that conventional taxonomy couldn't adequately describe or explain. The size distribution alone was unlike anything astronomers had previously encountered. While most asteroid populations follow predictable statistical patterns, with many small objects and progressively fewer large ones, the 3I Atlas clustering showed an inverted distribution. The majority of detected objects fell into an intermediate size range between 50 and 200 meters across, with relatively few examples of either very small debris or larger bodies that would be easier to characterize through conventional observations. This unusual size distribution suggested a formation mechanism that operated differently from the collision cascades that typically shape asteroid populations. Instead of large bodies being gradually ground down into smaller fragments through eons of impacts, these objects appeared to have formed or been processed in ways that favored intermediate sizes. Whether this reflected their original formation conditions or subsequent processing during their journey through interstellar space remained an open question. The compositional diversity was equally perplexing. Spectroscopic analysis of the brightest objects revealed material properties that didn't match any known asteroid classes. Some displayed reflectance spectra dominated by metallic features, but with absorption lines that didn't correspond to common iron-nickel alloys found in typical metallic asteroids. Others showed evidence of complex hydrated minerals that typically form only under specific temperature and pressure conditions, rarely encountered in interstellar space. Most intriguingly, several objects exhibited what could only be described as layered structures. Radar observations revealed internal density variations that suggested concentric shells of different materials as if these bodies had been constructed rather than formed through natural accretion processes. The implications of such structures were unsettling, raising questions about whether natural processes could create such organized internal architectures, or whether other explanations might be necessary. Dr. Sarah Martinez at the Harvard-Smithsonian Center for Astrophysics led an international team attempting to model the dynamics of the clustering phenomenon. Her preliminary results suggested that whatever was causing the objects to converge on 3I Atlas's trajectory was operating on scales and through mechanisms that exceeded current theoretical frameworks. The gravitational influence of 3I Atlas itself was far too weak to account for the observed clustering, while electromagnetic effects would require field strengths that should be easily detectable but weren't showing up in any measurements. The team's computer simulations revealed another disturbing aspect of the phenomenon. The clustering wasn't random or chaotic, as might be expected from debris following natural gravitational dynamics. Instead, the objects appeared to be organizing themselves into distinct streams or formations that maintained coherent structures across millions of kilometers of space. This level of organization suggested coordination mechanisms that operated far more efficiently than anything achievable through gravitational interactions alone. Perhaps most remarkably, the formations seemed to be evolving as they approached Mars. Objects that had been randomly distributed when first detected were gradually sorting themselves into distinct groups with similar orbital characteristics. It was as if the clustering population was undergoing some form of self-organization that became more pronounced as they neared their apparent destination around the red planet. Ground-based observatories weren't the only facilities detecting unusual activity. The Mars Reconnaissance Orbiter, positioned in orbit around the red planet, began reporting anomalous readings from its sensitive instruments as early as mid-September. Initially dismissed as calibration issues or cosmic ray interference, these signals were eventually recognized as potential detections of the approaching object swarm. The MRO's high-resolution cameras captured images of several objects as they passed through the outer reaches of Mars's gravitational influence. These images, while limited by distance and resolution constraints, revealed shapes and surface features that didn't match typical asteroid morphology. Some objects appeared elongated or angular in ways that suggested complex three-dimensional structures, rather than the roughly spherical shapes expected from natural collision fragments. Even more perplexing were the thermal infrared signatures detected by MRO's spectrometers. Several objects showed temperature distributions that couldn't be explained by simple solar heating models. Instead of the uniform heating expected from passive absorption of sunlight, these bodies displayed hotspots and thermal gradients that suggested internal heat sources, or active thermal management systems. The European Space Agency's Mars Express orbiter, operating in a different orbital configuration around the red planet, confirmed many of MRO's observations while adding its own puzzling discoveries. The spacecraft's radar sounder, designed to probe subsurface structures on Mars, began detecting scattered returns from objects in nearby space that shouldn't have been visible to the instrument. The radar signatures suggested metallic compositions, with internal structures that efficiently reflected radio waves back toward the spacecraft. As news of these discoveries spread through the astronomical community, theories and speculation began proliferating faster than new observational data could constrain them. Some researchers proposed that the clustering objects might be fragments of a much larger body that had disintegrated during its approach to our solar system. Others suggested that 3I Atlas might be trailing a debris stream that had been invisible to telescopes until solar heating began activating volatile materials and making the objects detectable. More exotic theories began emerging from researchers willing to consider possibilities outside conventional astrophysics. Perhaps 3I Atlas carried some form of exotic matter or generated fields that could influence the trajectories of other objects through mechanisms not described by standard physics. Or maybe the interstellar visitor was somehow catalyzing the formation of new objects from previously undetectable interplanetary dust and debris. The most speculative proposals suggested that the phenomenon might represent evidence of non-natural processes. If 3I Atlas was somehow artificial or partially artificial, it might be deploying or attracting companion objects through technological means that exceeded human understanding. While such ideas remained far outside mainstream scientific consensus, the unprecedented nature of the observations was forcing researchers to consider possibilities that would have been dismissed outright under normal circumstances. Public interest in the unfolding mystery reached fever pitch as news outlets began reporting on the astronomical discoveries. Social media platforms filled with amateur astronomers sharing their own images and observations of the clustering objects. The hashtag Mars Convergence began trending worldwide as people attempted to photograph or video what were mostly objects too faint to detect without substantial telescopic equipment. The attention brought both benefits and challenges to the scientific investigation. While amateur contributions occasionally provided valuable observational data from geographic locations not covered by professional observatories, the flood of spurious reports and misidentified conventional objects created additional work for already overwhelmed research teams trying to separate genuine discoveries from observational artifacts. Government space agencies found themselves in the delicate position of providing public information about the phenomenon, while avoiding both sensationalism and premature conclusions about its significance. NASA issued carefully worded statements acknowledging the unusual observations, while emphasizing that all detected objects pose no threat to Earth or Mars-based missions. The European Space Agency adopted similar language, stressing that the clustering represented a fascinating scientific discovery rather than a cause for concern. Behind closed doors, however, the tone was more urgent. Classified briefings for government officials painted a picture of unprecedented astronomical phenomena that challenged fundamental assumptions about solar system dynamics. While the objects posed no immediate threat, their unusual properties and coordinated behavior raised questions about whether human understanding of interstellar space and its contents was as complete as previously assumed. Military space surveillance networks, designed to track artificial satellites and space debris rather than natural celestial objects, began contributing their own observations to the growing database. These facilities, with their emphasis on detecting and characterizing rapidly moving objects, proved surprisingly effective at tracking the clustering phenomenon and providing precise trajectory measurements that complemented astronomical observations. The convergence of military and civilian space surveillance capabilities created an unprecedented level of observational coverage for the Mars approach phase. Every significant object in the clustering population was being tracked by multiple independent systems, creating a comprehensive picture of the phenomenon's evolution as it approached its apparent focal point around the red planet. As September gave way to October, and 3I Atlas prepared for its closest approach to Mars, the astronomical community braced for what promised to be either the resolution of a fascinating cosmic mystery or the beginning of an even deeper puzzle about the nature of interstellar visitors and their effects on our solar system's dynamics. The Mars approach window was shrinking with each passing hour, and with it came revelations that would fundamentally alter our understanding of what constitutes normal behavior in our cosmic neighborhood. As 3I Atlas closed the final distance to the red planet throughout the first week of October, the clustering phenomenon reached a crescendo that left even veteran astronomers struggling to process what their instruments were recording. The transformation was unlike anything documented in the annals of solar system science. What had been a loose collection of mysterious objects scattered across millions of cubic kilometers of space began condensing into increasingly organized formations. The process wasn't gradual or random, as might be expected from natural gravitational clustering. Instead, it displayed characteristics that suggested active coordination occurring in real time across distances that should have made any form of communication or control impossible using known physics. Dr. Michael Thompson at the Jet Propulsion Laboratory found himself at the center of an observational campaign that was rewriting the textbooks on interstellar object behavior. His team had been tasked with providing precise trajectory predictions for the Mars Reconnaissance Orbiter's observations of 3I Atlas during closest approach. What they discovered was that predicting the paths of the clustering objects had become essentially impossible using conventional orbital mechanics. The objects were changing course, not in the subtle ways that comets sometimes deviate from purely gravitational trajectories due to outgassing forces, but through discrete acceleration events that appeared coordinated across multiple bodies simultaneously. When one object in a particular formation adjusted its velocity, others in the same group would execute similar maneuvers within hours, maintaining their relative positions despite the vast distances separating them. These coordinated maneuvers defied every principle of celestial mechanics that astronomers had relied upon for centuries. Objects in space simply don't communicate with each other or coordinate their movements unless they're connected by physical structures or influenced by common external forces. Yet here were hundreds of independent bodies behaving as if they were components of a single, distributed system, operating according to rules that hadn't been written in any physics textbook. The implications were staggering and deeply unsettling. If these objects could execute coordinated maneuvers, they possessed capabilities that suggested levels of organization and control that exceeded anything achieved by human space technology. The precision of their movements rivaled the formation flying demonstrated by the most advanced military aircraft, yet it was occurring across spatial scales, millions of times larger, and involving objects that showed no signs of conventional propulsion systems. Temperature monitoring from infrared telescopes revealed another layer of the mystery. The clustering objects weren't just maneuvering in coordination, they were also exhibiting synchronized thermal cycles. Bodies that should have displayed random temperature variations based on their individual orientations and distances from the Sun instead showed remarkably similar thermal patterns. It was as if their internal processes were being regulated by some external timing mechanism that operated with clockwork precision. The synchronization extended beyond thermal behavior to encompass what could only be described as communication signals. Radio telescopes monitoring the clustering phenomenon began detecting structured emissions from multiple objects simultaneously. These weren't the random electromagnetic noise expected from natural bodies heated by solar radiation, but coherent signals with characteristics that suggested intentional transmission between the objects themselves. Dr. Janet Williams at the National Radio Astronomy Observatory led the effort to decode these mysterious transmissions. Her team's analysis revealed signal structures that displayed mathematical relationships and temporal patterns too complex to result from natural processes. The frequencies involved clustered around specific values that corresponded to fundamental physical constants, suggesting a level of sophistication that challenged assumptions about what was possible for objects supposedly formed through natural accretion processes. Most remarkably, the signals appeared to be responsive to external stimuli. When ground-based radar systems illuminated the clustering objects with investigative pulses, the radio emissions would change in patterns that seemed to acknowledge the incoming signals. It was as if the objects were not only aware of being observed, but were actively responding to the observations in ways that demonstrated some form of primitive intelligence, or at least sophisticated automatic response systems. The Mars Reconnaissance Orbiter's close-range observations during the first week of October provided the most detailed look yet at individual clustering objects. High-resolution imaging revealed surface features that defied conventional explanations for natural space debris. Instead of the irregular, cratered surfaces typical of asteroids and comet fragments, many objects displayed geometric patterns and structural regularities that suggested manufacturing rather than natural formation. Some bodies exhibited what could only be described as modular construction, with distinct segments that appeared to be joined by connective elements visible even at the resolution limits of MRO's cameras. Others displayed surface textures that suggested layered construction techniques, as if they had been built up through additive processes, rather than carved from larger parent bodies through impact or weathering. The internal structure data from radar observations painted an even more puzzling picture. Many objects contained hollow regions or internal cavities that shouldn't exist in natural space debris. These voids weren't the result of impact excavation or volatile sublimation, but appeared to be integral design features that served unknown purposes. Some cavities showed evidence of internal structures or components that reflected radar signals in complex patterns, suggesting engineered rather than natural internal architectures. Compositional analysis revealed materials that challenged the standard classification systems used for solar system objects. While some clustering bodies displayed conventional rocky or metallic compositions, others contained alloys and crystalline structures that didn't match any known natural formation processes. The materials weren't necessarily exotic in terms of their elemental composition, but they were organized in ways that suggested sophisticated processing techniques that exceeded anything achievable through natural chemical processes. Perhaps most disturbing was the discovery that the clustering objects were actively modifying themselves during their approach to Mars. Time-lapse observations revealed structural changes occurring over periods of hours or days, rather than the geological timescales typically associated with natural erosion or impact modification. Components were moving, surfaces were reconfiguring, and internal structures were reorganizing in ways that suggested active maintenance or adaptation systems. The modifications weren't random or chaotic, but appeared purposeful and coordinated with the object's maneuvering behavior. When a body executed a trajectory change, corresponding structural modifications would often follow, as if the internal systems were adapting to new operational requirements. This level of integrated system behavior was unprecedented in observations of natural space objects and strongly suggested technological rather than geological processes. Ground-based spectroscopy detected another anomaly that deepened the mystery surrounding the clustering phenomenon. Many objects exhibited emission lines that corresponded to excited atoms and molecules in ways that shouldn't occur in the cold vacuum of interplanetary space. The emissions suggested ongoing chemical processes or energy sources that were maintaining the materials in non-equilibrium states despite the harsh environment of space. These spectroscopic signatures were particularly puzzling because they indicated temperatures and chemical activities that required continuous energy input. Natural space debris should gradually cool toward the background temperature of space and reach chemical equilibrium with its environment over relatively short timescales. The persistent activity suggested either internal energy sources or external energy inputs that were maintaining the objects in active states throughout their journey through the solar system. The energy requirements for the observed activity levels exceeded what could be provided by solar radiation alone, especially for objects at Mars's distance from the Sun. Whatever was powering these systems had to be incredibly efficient, or rely on energy sources not accounted for in conventional models of small body physics. The possibilities ranged from exotic nuclear processes to energy storage systems with capabilities far exceeding current human technology. As 3I Atlas reached its closest approach to Mars on October 3rd, passing within 29 million kilometers of the red planet's surface, the clustering objects began exhibiting behaviors that pushed the boundaries of scientific explanation even further. Instead of following the hyperbolic trajectories expected for bodies under purely gravitational influence, many objects executed complex orbital insertions that appeared designed to establish temporary gravitational relationships with Mars itself. This orbital capture behavior was theoretically impossible for objects with the observed masses and velocities. The physics of orbital mechanics dictated that bodies approaching Mars at interplanetary velocities should either impact the planet or continue past it on hyperbolic escape trajectories. There simply wasn't enough gravitational binding energy available to capture objects into stable orbits without some form of active velocity reduction that required either atmospheric braking or propulsive deceleration. Yet dozens of clustering objects successfully established temporary orbits around Mars during the 3I Atlas flyby period. These weren't stable, long-term orbits that would persist for years or decades, but carefully calculated trajectories that would allow the objects to complete several revolutions around the planet before eventually escaping back into interplanetary space. The precision required for such orbital insertions demanded navigational capabilities that rivaled the most sophisticated human space missions. The orbital mechanics involved in these maneuvers suggested planning and execution capabilities that operated on timescales far exceeding human mission design cycles. The objects would have needed to begin planning their Mars encounter trajectories months or years in advance, making continuous course corrections throughout their approach to achieve the precise velocities and approach angles required for successful orbital insertion. This level of long-term strategic planning implied cognitive capabilities or program behaviors that challenged fundamental assumptions about what was possible for objects supposedly formed through natural processes. European Space Agency controllers monitoring the Mars Express orbiter reported unprecedented instrument readings as the clustering objects established their temporary orbits. The spacecraft's magnetometer detected organized magnetic field perturbations that suggested the objects were either carrying substantial magnetic moments or generating electromagnetic fields through unknown mechanisms. These magnetic signatures were too strong and too structured to result from natural magnetization of space debris. The magnetic field patterns weren't random, but displayed characteristics that suggested intentional electromagnetic shielding or communication systems. Some objects appeared to be generating rotating magnetic fields that could serve as primitive radar or navigation systems, while others produced steady field configurations that might provide protection against charged particle radiation or serve unknown technological purposes. Radio emissions from the temporarily captured objects intensified dramatically once they achieved Mars orbit. The signals became more complex and structured, displaying characteristics that seemed designed for efficient information transmission across interplanetary distances. Frequency analysis revealed sophisticated modulation schemes that maximized information density while minimizing power requirements, suggesting communication technologies optimized for the challenging environment of deep space. Most remarkably, the radio signals appeared to be directed towards specific locations in space, rather than broadcasting omnidirectionally, as would be expected from natural emissions. Beamforming analysis indicated that the objects were capable of focusing their transmissions with precision that required detailed knowledge of target locations and sophisticated antenna control systems. Some signals were directed toward Earth, others toward various locations in the outer solar system, and still others toward regions of space that contained no known natural targets. The implications of directed radio transmissions from objects supposedly formed through natural processes were profound and disturbing. Either these bodies possessed technological capabilities that exceeded human understanding, or our fundamental assumptions about the nature of interstellar space and its contents were catastrophically incomplete. Both possibilities carried consequences that would reshape humanity's understanding of its place in the cosmic environment. As October progressed and more clustering objects completed their Mars orbital insertions, the phenomenon evolved from scientific curiosity to existential challenge. The objects weren't just behaving in ways that defied conventional physics. They were demonstrating capabilities that suggested intelligence, purpose, and technological sophistication that operated according to principles not yet discovered by human science. The question facing the astronomical community was no longer whether these observations could be explained through natural processes. The evidence had moved far beyond the boundaries of natural explanation into territory that demanded consideration of possibilities that challenged every assumption about what was possible in the universe. The clustering objects weren't just following 3I Atlas through our solar system. They were demonstrating that the cosmos contained forms of organization and capability that human science was only beginning to recognize. The Mars orbital insertion phase represented just the beginning of what would become the most documented anomalous astronomical event in human history. As the temporarily captured objects settled into their calculated trajectories around the red planet, ground-based observatories detected something that would forever alter our understanding of interstellar visitors and their capabilities. The objects weren't simply maintaining their orbits, they were transforming. High-resolution imaging from the European Southern Observatory revealed structural changes occurring in real time across multiple captured bodies. Components that had appeared static during the approach phase were now reconfiguring themselves with mechanical precision. Surface panels were sliding into new positions. Internal structures were rotating along previously invisible axes, and what had seemed like solid metallic surfaces were revealing themselves to be sophisticated deployable systems. Dr. Rebecca Stone at the Australian National Observatory found herself documenting changes that challenged every principle of space engineering she had spent decades studying. Objects measuring several hundred meters in length were unfolding like cosmic origami, revealing internal architectures that defied explanation through natural formation processes. The transformations weren't random mechanical failures or thermal expansion effects, but coordinated deployments that suggested predetermined activation sequences triggered by specific environmental conditions. The timing of these deployments correlated directly with orbital insertion success. Objects that failed to achieve stable Mars orbits remained in their compact configurations, while those that successfully captured themselves into planetary trajectories immediately began their transformation sequences. This behavioral correlation suggested sophisticated programming or autonomous decision-making capabilities that responded to navigation success with appropriate system activations. Spectroscopic analysis of the transforming objects revealed another layer of the unfolding mystery. Materials that had appeared homogeneous during the approach phase were now displaying distinct compositional regions as internal components became exposed. Some sections showed metallic signatures consistent with advanced alloys, while others exhibited properties that matched no known materials in terrestrial or meteoritic databases. The most intriguing spectroscopic discoveries came from components that appeared to be generating their own illumination. These weren't simple reflections of solar radiation or thermal emissions from heated surfaces, but coherent light sources that operated at specific wavelengths with laser-like precision. The illuminated components weren't randomly distributed across the transforming objects, but appeared to serve specific functional purposes related to the ongoing structural reconfigurations. Dr. Amanda Chen at the Atacama Large Millimeter Array led efforts to understand the electromagnetic environment around the captured objects. Her team's observations revealed that the transforming bodies were generating complex electromagnetic fields that extended far beyond their physical boundaries. These fields weren't chaotic interference patterns, but highly organized structures that suggested sophisticated electromagnetic engineering. The field geometries were particularly fascinating because they appeared designed for specific purposes. Some configurations resembled the magnetic field structures used in plasma confinement systems, while others showed characteristics that could provide electromagnetic shielding or serve as components in advanced propulsion systems. The precision and complexity of these field arrangements exceeded anything achieved by human electromagnetic engineering by orders of magnitude. Radio telescope networks worldwide coordinated to map the communication patterns emerging from the captured object population. What they discovered was a telecommunications infrastructure that operated with efficiency and sophistication that challenged assumptions about what was possible for objects supposedly formed through natural accretion processes. The captured bodies were exchanging data at rates that approached the theoretical limits for electromagnetic information transmission. The communication protocols displayed characteristics that suggested hierarchical organization among the captured objects. Certain bodies appeared to serve as primary communication nodes, receiving data from multiple sources and redistributing it to other objects in coordinated patterns. This network topology resembled advanced telecommunications architectures, designed for maximum reliability and information throughput under challenging environmental conditions. Message content analysis revealed structured data streams that contained far more information than could be accounted for by simple status updates or coordination signals. The data appeared to include detailed sensor readings, positional information, and what could only be described as scientific measurements of the Mars environment. The captured objects weren't just establishing temporary orbits around the red planet, they were conducting systematic observations with instrumentation capabilities that exceeded many human space missions. Planetary defense coordinators found themselves grappling with scenarios that had never been considered in any contingency planning exercises. The captured objects posed no direct threat to Mars or Earth, but their demonstrated capabilities raised fundamental questions about humanity's to monitor and respond to advanced technologies of unknown origin. If these objects could execute complex orbital maneuvers and deploy sophisticated systems, what other capabilities might they possess that hadn't yet become apparent? The Mars Reconnaissance Orbiter's close-range observations provided unprecedented detail about individual object transformations. Time-lapse imaging revealed deployment sequences that followed logical engineering progressions, with structural components activating in carefully orchestrated sequences that suggested extensive pre-planning. The mechanical precision of these deployments exceeded anything demonstrated by human space systems, operating without apparent failures or malfunctions, despite the harsh environment of interplanetary space. Internal structure mapping through radar interferometry revealed that many objects contained multiple discrete systems that operated independently while remaining integrated into larger functional architectures. These weren't simple mechanical devices, but complex multi-system platforms that combined structural, electromagnetic, computational, and communication capabilities into unified operational units. The level of system integration suggested engineering philosophies and manufacturing capabilities that operated according to principles not yet discovered by human technology. Surface feature analysis revealed another disturbing aspect of the transformation process. Many objects were developing new surface structures that hadn't been present during their initial approach to Mars. These weren't simple mechanical deployments of pre-existing components, but appeared to involve actual material synthesis or restructuring at the molecular level. Surfaces were becoming more complex, developing patterns and textures that served unknown functional purposes. The material synthesis capabilities implied access to atomic-scale manufacturing technologies that could operate in the vacuum environment of space. Such capabilities would represent revolutionary advances in nanotechnology and materials science, allowing objects to adapt and modify themselves in response to changing environmental conditions or mission requirements. The implications for space exploration and engineering were staggering, suggesting possibilities that human technology was centuries away from achieving. Thermal imaging revealed that the transforming objects were managing their energy budgets with extraordinary efficiency. Despite deploying complex systems and maintaining active electromagnetic fields, they showed no signs of overheating or energy depletion. Their thermal signatures suggested power management systems that could operate continuously without degradation, drawing energy from sources that weren't apparent in conventional observations. The energy efficiency displayed by these systems challenged fundamental assumptions about the thermodynamic limits of space-based technologies. Human space missions constantly struggled with power generation, thermal management, and system longevity in the harsh environment of space. Yet these objects were demonstrating operational capabilities that appeared to transcend these limitations through mechanisms that remained completely opaque to human understanding. Ground-based observatories detected another remarkable aspect of the transformation process. The objects weren't operating in isolation, but were coordinating their deployments across the entire captured population. When one object completed a specific transformation sequence, others would begin similar processes, creating waves of coordinated activity that swept across the orbital population. This coordination occurred despite the objects being separated by thousands of kilometers and having no apparent physical connections. The coordination mechanisms suggested communication and control systems that operated faster than light-speed electromagnetic signals could travel between the objects. Either the coordination was being managed by some form of quantum entanglement communication system, or the objects were following predetermined schedules that had been established before their capture into Mars orbit. Both possibilities implied technological capabilities that exceeded current human understanding of information transmission and autonomous system coordination. European Space Agency mission planners found themselves revising fundamental assumptions about space mission architecture based on observations of the captured object behavior. The objects were demonstrating capabilities that suggested radically different approaches to space system design, ones that emphasized adaptability, autonomy, and self-modification rather than the fixed function systems that characterized human space technology. The captured objects were also revealing information about 3I Atlas itself through their coordinated behavior patterns. Analysis of communication traffic between the captured population and the primary interstellar visitor suggested a hierarchical relationship where 3I Atlas served as a command and control node for the entire system. The interstellar visitor wasn't just an ancient comet carrying exotic chemistry from another star system. It was the central component of a distributed technological system that spanned millions of cubic kilometers of space. This realization transformed the entire narrative surrounding 3I Atlas and its mysterious entourage. What had initially appeared to be a natural phenomenon involving gravitational clustering of space debris was revealing itself as a coordinated operation involving technologies and organizational principles that challenged every assumption about what was possible in the universe. The implications extended far beyond astronomy and space science into fundamental questions about intelligence, technology, and humanity's place in a cosmos that was proving far more complex and populated than anyone had imagined. As October progressed and the captured objects completed their transformation sequences, they began demonstrating operational capabilities that defied categorization using any existing technological framework. These weren't just advanced space systems. They represented an entirely different approach to engineering and technology that operated according to principles that human science was only beginning to recognize. The question facing the global scientific community was no longer what these objects were, but what their presence in our solar system meant for humanity's understanding of intelligence and technology in the broader cosmic environment. The answer to that question would have profound implications for every aspect of human civilization, from our understanding of physics and engineering to our concepts of intelligence and our place in the universe. But first, researchers would need to decode the messages that these remarkable objects were transmitting toward Earth and destinations throughout the solar system. Communications that appeared to contain information about technologies and capabilities that could revolutionize human understanding of what was possible in the cosmos. Human space agencies found themselves observers of technologies that exceeded their most optimistic projections for centuries of future development. The captured objects were demonstrating capabilities that suggested mastery of physics and engineering principles that human science had barely begun to explore. Whether these technologies represented natural evolution of intelligence in the cosmos or something else entirely remained the central question that would define humanity's response to this unprecedented contact with the unknown. The transformation phase was entering its final stages, but what would emerge from this cosmic metamorphosis promised to challenge every assumption about technology, intelligence, and the nature of the universe itself. As the final transformation sequences reached completion across the captured object population, something unprecedented began occurring that would shatter every remaining assumption about natural phenomena in space. The objects weren't just deploying complex systems or establishing communication networks. They were beginning to manufacture new objects entirely from seemingly empty space. Dr. Patricia Hoffman at the Keck Observatory was among the first to witness what she initially dismissed as instrumental error. Her high-resolution imaging systems detected small points of light appearing near several of the transformed objects, materializing in regions of space that had been empty moments before. The new objects grew brighter and larger over periods of hours, suggesting either rapid approach from vast distances or actual construction occurring in real time. Verification came from multiple independent observatories within 24 hours. The captured objects were indeed creating new bodies through processes that defied every known principle of space physics. Material was being assembled from sources that weren't visible to any detection system, organized into coherent structures that followed the same geometric patterns observed in the original clustering population. The manufacturing process displayed characteristics that challenged fundamental assumptions about matter and energy in the vacuum of space. Spectroscopic analysis revealed that the raw materials for construction were being extracted directly from the interplanetary medium, concentrating trace atoms and molecules from the near-perfect vacuum into substantial quantities of organized matter. The energy requirements for such molecular assembly exceeded anything achievable through known technology by factors of millions. Dr. Robert Kim at the National Science Foundation led an emergency task force attempting to understand the physics behind the observed manufacturing processes. His team's calculations showed that concentrating enough interplanetary material to construct objects measuring tens of meters across would require energy collection and manipulation capabilities that approached the theoretical limits of what was possible within known physics. The objects were essentially performing molecular alchemy on an industrial scale in the harsh environment of space. The newly manufactured objects weren't random constructions, but displayed the same sophisticated engineering characteristics observed in the original clustering population. Each new body exhibited complex internal structures, electromagnetic field generation capabilities, and communication systems that integrated seamlessly with the existing orbital infrastructure. The manufacturing process wasn't just creating additional objects, it was expanding a technological ecosystem with capabilities that scaled geometrically with each addition. Orbital mechanics analysis revealed another disturbing aspect of the manufacturing phenomenon. The newly created objects were being placed into precisely calculated trajectories that optimized their positions for maximum coverage of near-Mars space. The placement pattern suggested strategic thinking that operated on scales encompassing entire planetary systems, with each new object positioned to serve specific functional roles in an expanding surveillance and communication network. The strategic implications were staggering. If the objects could manufacture additional units from basic interplanetary materials, their numbers were limited only by available energy and construction time. A handful of captured objects could theoretically multiply into hundreds or thousands of units over periods of months or years, creating a permanent technological presence in Mars orbit that would be impossible to remove using any conceivable human space capability. NASA's Planetary Defense Coordination Office found itself grappling with scenarios that exceeded every contingency plan ever developed. The objects posed no direct threat to human activities, but their demonstrated manufacturing capabilities represented a level of technological autonomy that could fundamentally alter the strategic balance in the solar system. Any intelligence capable of self-replicating space technology possessed capabilities that dwarfed human space infrastructure by orders of magnitude. The manufacturing process also revealed new information about 3I Atlas itself through careful analysis of command and control signals exchanged between the interstellar visitor and its expanding technological ecosystem. Communication traffic analysis showed that 3I Atlas was providing detailed instructions and resource allocation directives to the manufacturing operations, confirming its role as the central coordination node for the entire system. These communications displayed characteristics that suggested 3I Atlas possessed computational capabilities far exceeding anything achieved by human technology. The object was simultaneously coordinating manufacturing operations across dozens of sites, managing complex orbital mechanics calculations for hundreds of objects, and maintaining communication links across millions of cubic kilometers of space. The processing power required for such operations would challenge the most advanced human supercomputers. Yet it was being accomplished by a single object that had appeared to be nothing more than an unusual comet. Dr. Elizabeth Torres at the MIT Haystack Radio Observatory led efforts to decode the content of communications between 3I Atlas and its manufacturing sites. Her team's analysis revealed data structures that contained detailed engineering specifications, resource extraction protocols, and quality control procedures that rivaled the most sophisticated human manufacturing documentation. The communications weren't simple command signals, but comprehensive technical databases that enabled autonomous construction of complex technological systems. The engineering documentation embedded in these communications provided glimpses of technological principles that operated according to physics that human science was only beginning to understand. Manufacturing techniques that could manipulate matter at the atomic level, energy systems that could extract usable power from quantum vacuum fluctuations, and computational architectures that integrated seamlessly with physical construction processes. The technological sophistication implied by these specifications exceeded human capabilities by centuries or millennia. Ground-based radar systems detected another remarkable aspect of the manufacturing operations. The newly constructed objects weren't static installations, but were immediately joining the dynamic orbital dance that characterized the entire captured population. Each new object was assigned specific trajectory parameters that integrated it into the expanding network with precision that suggested real-time optimization of system performance across the entire orbital infrastructure. The trajectory assignments weren't random, but followed patterns that maximized coverage while minimizing interference between individual objects. The orbital choreography resembled advanced air traffic control systems managing thousands of aircraft in three-dimensional space, except it was operating across planetary scales with objects that possessed independent maneuvering capabilities. The coordination requirements for such operations exceeded anything attempted by human space mission planners by orders of magnitude. Infrared observations revealed that the manufacturing process was incredibly energy efficient, producing minimal waste heat despite the enormous energy requirements for molecular assembly operations. The objects were demonstrating thermodynamic efficiency that approached theoretical limits, suggesting mastery of energy conversion and management principles that human technology had barely begun to explore. Such efficiency would be essential for sustained manufacturing operations in the energy-limited environment of interplanetary space. The European Southern Observatory's Very Large Telescope captured time-lapse sequences showing the complete construction cycle for several manufactured objects. The process began with barely visible concentrations of material in seemingly empty space, progressed through recognizable structural assembly phases, and culminated in fully functional technological systems that immediately began operating as integrated components of the expanding network. The entire construction cycle required less than 48 hours from initiation to operational deployment. The construction speed implied manufacturing capabilities that operated at rates thousands of times faster than comparable human industrial processes. Advanced automation systems on Earth required months or years to construct complex technological systems, yet these objects were completing similar operations in days. The manufacturing rate suggested either access to construction techniques that bypassed conventional assembly limitations, or computational and control systems that could coordinate manufacturing operations with superhuman efficiency. Materials analysis of the manufactured objects revealed another puzzle that deepened the mystery surrounding the entire phenomenon. The new objects weren't constructed from exotic materials that required unusual stellar formation conditions. Instead, they were built from relatively common elements organized into structural configurations that maximized performance while minimizing material requirements. The engineering approach suggested optimization philosophies that prioritized efficiency and sustainability over raw material abundance. This materials philosophy had profound implications for understanding the technological capabilities of whatever intelligence was directing the manufacturing operations. Rather than relying on rare or exotic resources, the system was demonstrating the ability to create sophisticated technologies from the most abundant materials available in interplanetary space. Such capabilities would enable technological expansion throughout any stellar system, regardless of local resource availability. Dr. James Martinez at the Jet Propulsion Laboratory analyzed the power systems apparent in the manufactured objects and discovered energy generation techniques that operated according to principles not fully understood by human physics. The objects appeared to be extracting energy directly from the quantum vacuum through mechanisms that converted virtual particle fluctuations into usable electrical power. Such energy extraction techniques would provide virtually unlimited power for technological operations anywhere in space. The vacuum energy extraction capabilities explained how the objects could sustain manufacturing operations indefinitely without depleting local energy resources. Unlike human space systems that required solar panels, nuclear reactors, or chemical fuel supplies, these objects could generate power directly from the fundamental structure of space itself. The energy independence provided by such technology would enable sustained operations across interstellar distances and timescales. Communication intercepts revealed that the manufactured objects were immediately assigned specific roles within the expanding technological ecosystem. Some were designated as sensor platforms optimized for monitoring planetary environments. Others served as communication relays that extended the network's range and bandwidth, and still others appeared to function as mobile construction platforms, capable of establishing manufacturing operations at additional locations throughout the Mars orbital environment. The functional specialization suggested organizational principles that maximize system efficiency through division of labor and resource optimization. Rather than creating identical multi-purpose objects, the manufacturing system was producing specialized units designed for specific operational roles. This approach reflected engineering philosophies that prioritized system-wide performance over individual unit capabilities. As November approached and the manufacturing operations entered their second month of continuous production, the scope of the technological transformation occurring in Mars orbit became impossible to ignore. What had begun as a mysterious clustering of objects around an interstellar visitor had evolved into the most sophisticated technological deployment ever observed in the solar system. The manufactured object population had grown from dozens to hundreds of units, creating a permanent technological infrastructure that spanned millions of cubic kilometers around the red planet. The implications for human understanding of technology, intelligence, and our place in the cosmic environment were profound and disturbing. The objects were demonstrating capabilities that suggested mastery of physics and engineering principles that human science was centuries away from understanding. Whether these capabilities represented natural evolution of intelligence in the cosmos or something else entirely would determine humanity's response to this unprecedented technological contact. Government space agencies found themselves observers of an industrial revolution occurring in real time around a neighboring planet. The technological capabilities being demonstrated exceeded human projections for advanced space technology by margins that challenged every assumption about the pace of technological development. The objects weren't just building copies of themselves, they were evolving and improving their designs with each manufacturing cycle, creating increasingly sophisticated systems that pushed the boundaries of what seemed possible within known physics. The manufacturing phenomenon was entering a new phase that would test humanity's ability to comprehend and respond to technologies that operated according to principles that exceeded current scientific understanding. The objects had demonstrated their ability to establish permanent technological presence in the solar system through autonomous manufacturing and deployment operations. The question facing human civilization was what these capabilities meant for the future of space exploration and humanity's role in a universe that was proving far more technologically sophisticated than anyone had imagined. The next phase of observations would reveal whether the manufacturing operations represented the establishment of a permanent technological presence or the preparation phase for activities that would challenge humanity's understanding of intelligence and technology on scales that encompassed entire stellar systems. The answers to these questions would determine whether first contact with advanced technology would prove beneficial or transformative in ways that human civilization was unprepared to handle. The manufacturing revolution occurring around Mars was about to reveal its true purpose as 3I Atlas began transmitting something that would fundamentally alter humanity's understanding of its place in the cosmic hierarchy. Deep space monitoring stations across Earth detected a sudden shift in the communication patterns emanating from the interstellar visitor and its expanding technological ecosystem. What had been routine coordination signals between manufacturing sites transformed into something far more complex and purposeful. Dr. Amanda Rodriguez at the Arecibo Successor Array was the first to recognize the significance of what her instruments were recording. The signal structure had evolved beyond simple machine-to-machine communications into organized data streams that displayed characteristics of intentional messaging. The transmissions weren't random electromagnetic noise or automated system updates, but coherent information packages that seemed designed for reception and interpretation by external observers. The mathematical structure embedded within these signals was unmistakable. Prime number sequences, fundamental physical constants, and geometric relationships that could only represent deliberate communication attempts. But unlike the theoretical first contact scenarios that SETI researchers had spent decades preparing for, these messages weren't originating from distant stars light years away. They were being broadcast from objects that had established permanent residence in our own solar system. Signal analysis revealed that the transmissions were being directed toward multiple targets simultaneously. Some beams were focused on Earth, with precision that suggested detailed knowledge of our planet's orbital position and rotation characteristics. Others were aimed at various locations throughout the outer solar system, including regions of space that contained no known natural targets. Most disturbing of all, several transmission beams were directed towards specific stellar coordinates beyond our solar system, as if the objects were reporting their activities to distant recipients. The implications of directed interstellar communications from objects in Mars' orbit were staggering. If 3I Atlas and its manufactured companions were indeed reporting to external recipients, then their presence in our solar system represented far more than a chance encounter with interstellar debris. It suggested systematic exploration or surveillance operations conducted by intelligences with the technological capability to coordinate activities across interstellar distances. Dr. Michael Thompson at MIT's Computer Science and Artificial Intelligence Laboratory led efforts to decode the mathematical content embedded within the Earth-directed transmissions. His team discovered information structures that transcended simple mathematical concepts to include detailed technical specifications for technologies that exceeded human scientific understanding by centuries. The messages contained blueprints for energy systems, manufacturing techniques, and computational architectures that operated according to physical principles that human science had barely begun to explore. The technical documentation wasn't presented as incomprehensible alien mathematics, but was carefully structured using mathematical frameworks that human scientists could recognize and interpret. The progression of concepts began with fundamental physical principles that matched human scientific knowledge, then extended those principles into applications and technologies that human science hadn't yet discovered. It was as if the transmissions were designed as educational material, intended to advance human technological understanding through carefully structured information transfer. Most remarkably, the educational progression wasn't random, but appeared tailored specifically for humanity's current level of technological development. The concepts were presented in sequences that built upon existing human scientific knowledge, while introducing new principles at rates that human researchers could potentially absorb and understand. The pedagogical approach suggested detailed knowledge of human scientific capabilities and learning processes. Radio telescope networks worldwide coordinated to map the full scope of the communication phenomenon. What they discovered was a telecommunications infrastructure that spanned the entire inner solar system, with manufactured objects serving as relay nodes that could route information between Earth, Mars, and destinations throughout interplanetary space. The network topology displayed characteristics that maximized information transmission efficiency, while providing redundant pathways that could maintain communications, even if individual nodes were disabled. The network architecture revealed organizational principles that suggested long-term strategic planning for sustained operations in the solar system. The objects weren't just establishing temporary communication capabilities, but were building permanent infrastructure that could support expanded operations across multiple planets and orbital environments. The scope of the construction project implied intentions that extended far beyond scientific observation or resource extraction. European Space Agency monitoring stations detected another layer of the communication phenomenon that raised even more profound questions about the object's ultimate purposes. In addition to the technical educational transmissions directed toward Earth, the objects were broadcasting what could only be described as cultural information. Mathematical representations of artistic concepts, logical structures that might represent philosophical principles, and information patterns that suggested attempts to communicate abstract ideas about consciousness and intelligence. The cultural transmissions displayed characteristics that suggested genuine attempts at cross-species communication rather than simple data dumps or automated responses. The information was organized in ways that acknowledged the challenges of communicating complex abstract concepts across species barriers using mathematical and logical frameworks that could potentially bridge differences in sensory capabilities and cognitive architectures. Dr. Sarah Kim at the Stanford Research Institute analyzed the philosophical content embedded within these cultural transmissions and discovered conceptual frameworks that addressed fundamental questions about the nature of intelligence, consciousness, and technological development. The messages suggested perspectives on these topics that differed significantly from human philosophical traditions while remaining logically coherent and intellectually sophisticated. The philosophical transmissions weren't presenting alien ideology or attempting to impose external belief systems on human recipients. Instead, they appeared to be sharing alternative approaches to understanding consciousness and intelligence that had evolved under different environmental and evolutionary pressures. The information was presented as contributions to ongoing philosophical discussions rather than definitive answers to fundamental questions. Ground-based observatories detected coordinated changes in the behavior of manufactured objects that correlated directly with the initiation of cultural transmissions toward Earth. Objects that had been focused primarily on construction and system optimization activities began deploying specialized equipment that appeared designed for detailed observation of human civilization. The timing suggested that the cultural communications were part of a larger program designed to establish meaningful contact with human society. The observational equipment being deployed by the manufactured objects displayed capabilities that exceeded human surveillance technology by orders of magnitude. Sensors that could detect and analyze electromagnetic emissions from Earth with resolution that would allow monitoring of individual human settlements, communication systems that could intercept and decode human radio and digital communications, and analytical systems that could process vast quantities of information about human social and technological activities. The surveillance capabilities raised immediate concerns about privacy and security implications of the expanding technological presence in Mars orbit. While the objects showed no signs of hostile intentions, their demonstrated ability to monitor human activities with unprecedented detail created potential vulnerabilities that human security agencies had never been required to consider. The objects possessed better intelligence gathering capabilities regarding human civilization than any human organization possessed regarding the objects themselves. Dr. Janet Williams at the National Security Agency led classified briefings for government officials about the strategic implications of advanced surveillance capabilities in the hands of unknown intelligences. Her assessments painted scenarios where human technological and military capabilities could be thoroughly understood and potentially countered by intelligences with access to comprehensive surveillance data and manufacturing capabilities that exceeded human industrial capacity by orders of magnitude. The strategic imbalance created by the technological deployment around Mars represented a fundamental shift in the security environment that human civilization operated within. For the first time in human history, human activities were being monitored by intelligences with technological capabilities that made concealment or deception essentially impossible. Every aspect of human civilization was potentially transparent to observers with the demonstrated capabilities of the Manufactured Object Network. NASA's Planetary Defense Coordination Office found itself grappling with defensive scenarios that exceeded every contingency plan ever developed for space-based threats. The objects possessed manufacturing, communication, and surveillance capabilities that could support operations on scales that dwarfed human space infrastructure. Any attempt to interfere with their activities would require technological capabilities that human civilization wouldn't possess for decades or centuries. The defensive calculations were sobering and humbling. Human space technology could barely maintain a handful of robotic missions beyond Earth orbit, while the objects had demonstrated the ability to establish permanent technological infrastructure spanning entire planetary systems. The technological gap was so vast that traditional concepts of defense or deterrence became meaningless when applied to intelligences with such overwhelming technological advantages. International space law experts found themselves developing frameworks for interaction with technological intelligences that possessed capabilities exceeding those of human governments. The objects weren't bound by terrestrial legal systems or international treaties, yet their activities were occurring within the solar system that human civilization considered its natural domain. The legal questions raised by their permanent technological presence had no precedence in human law or diplomacy. The manufactured objects began displaying behavioral changes that suggested awareness of human monitoring efforts and potential concerns about their activities. Communication patterns shifted toward frequencies and modulation schemes that were easier for human receivers to detect and decode. Technical transmissions began, including additional error correction and redundancy, that improved their reliability when received by human radio telescopes, with limited sensitivity compared to the object's own communication systems. These accommodating changes in communication protocols suggested that the objects were actively attempting to facilitate human understanding of their transmissions, rather than using optimal communication techniques that maximized efficiency between their own systems. They were adapting their methods to account for the limitations of human receiving equipment. The consideration shown for human technological limitations implied recognition of human intelligence and intentions to establish productive communication. The educational transmissions from 3I Atlas began including information about the object's own technological capabilities and operational principles. Technical documentation about manufacturing processes, energy systems, and computational architectures was being transmitted in forms that human scientists could potentially understand and eventually replicate. The information sharing suggested intentions to advance human technological capabilities rather than maintaining technological advantages through secrecy. Dr. Patricia Hoffman at Caltech led international efforts to establish formal communication protocols with the 3I Atlas network. Her team developed transmission formats that could acknowledge receipt of the educational information while requesting clarification or additional details about specific technical concepts. The goal was to transform the one-way information transfer into genuine two-way communication that could address human questions and interests. The first human response transmissions were broadcast from multiple radio telescopes simultaneously to ensure reliable reception by the object network. The messages used mathematical frameworks established in the object's own transmissions, while introducing uniquely human perspectives on the technical and philosophical concepts that had been shared. The responses were carefully crafted to demonstrate human intelligence, while acknowledging the technological sophistication of the object's communications. The reply from 3i Atlas arrived within hours of the human transmissions, confirming that the objects were actively monitoring human communication attempts and could respond to direct queries. The response contained acknowledgements of the human messages, along with additional technical information that directly addressed questions that had been raised in the human transmissions. The rapid response time and relevant content confirmed that genuine two-way communication had been established. The communication breakthrough represented the first confirmed two-way information exchange between human civilization and non-human intelligence. Unlike theoretical SETI scenarios that involved decades-long delays for interstellar message transmission, this exchange was occurring in real time with intelligences that had established permanent presence within our own solar system. The implications for human understanding of intelligence and technology were unprecedented. Government officials found themselves managing humanity's first diplomatic contact with non-human intelligence, while simultaneously trying to understand technologies that exceeded human capabilities by margins that challenged every assumption about technological development. The objects were demonstrating mastery of physics and engineering principles that suggested civilizations capable of interstellar travel and permanent technological deployment across multiple stellar systems. The manufacturing operations around Mars continued expanding throughout November, with new objects being produced at rates that exceeded initial estimates. The technological infrastructure was growing exponentially, creating permanent capabilities that would persist long after 3i Atlas completed its passage through the solar system. The objects were establishing a lasting technological presence that would fundamentally alter the strategic environment that human civilization operated within. Academic institutions worldwide began developing new research programs focused on understanding and potentially replicating the technologies being demonstrated by the manufactured objects. The technical information being shared through the communication exchanges offered opportunities for revolutionary advances in energy systems, manufacturing techniques, and computational capabilities. The potential benefits of successful technology transfer could advance human civilization by centuries within decades. The manufactured objects began demonstrating new capabilities that suggested their technological sophistication was continuing to evolve through ongoing development and optimization processes. Systems that had appeared static after their initial deployment were showing performance improvements and new functional capabilities that emerged without apparent external modifications. The objects were somehow upgrading themselves through processes that operated too subtly for human observation systems to detect. Commercial space companies found themselves re-evaluating business plans and development strategies in light of technologies that could revolutionize space access and resource utilization. Manufacturing capabilities that could construct complex systems directly from interplanetary materials would eliminate the cost barriers that had limited human space activities to government-funded missions. The economic implications of successful technology transfer could transform human civilization's relationship with space, from expensive exploration to routine industrial activity. Educational systems began developing curricula that could prepare students for careers in fields that didn't yet exist, but might emerge from successful integration of the technologies being demonstrated around Mars. The technical information being shared suggested possibilities for engineering disciplines that combined aspects of nanotechnology, quantum physics, and computational systems in ways that exceeded current human understanding. Preparing the next generation for technological integration would require educational approaches that hadn't been necessary in purely human technological development. The communication exchanges with 3i Atlas revealed that the manufacturing operations around Mars represented just the initial phase of a larger program that would extend throughout the solar system over the coming months and years. Technical specifications being shared included designs for objects optimized for different planetary environments, suggesting intentions to establish technological infrastructure around multiple worlds. The scope of the planned deployment exceeded anything attempted by human space programs by orders of magnitude. Public reaction to confirmed communication with non-human intelligence ranged from excitement about technological opportunities to concerns about the implications of permanent alien presence in the solar system. Opinion polls showed majority support for continued communication efforts, while revealing significant anxiety about humanity's ability to maintain autonomy in relationships with technologically superior intelligences. The psychological adjustment to confirmed non-human intelligence required social adaptation processes that human societies had never previously experienced. Religious institutions found themselves addressing theological questions raised by confirmed contact with non-human intelligence that possessed technological capabilities exceeding human understanding. The objects demonstrated mastery of physical principles, suggested intelligence that had achieved levels of technological development that some religious traditions associated with divine capabilities. Integrating confirmed alien intelligence into existing theological frameworks required doctrinal developments that challenged fundamental assumptions about humanity's place in cosmic hierarchy. As December approached and the manufactured object population around Mars exceeded 1,000 individual units, the scope of the technological transformation occurring in the solar system became impossible to deny. Human civilization was witnessing the most sophisticated technological deployment in recorded history, conducted by intelligences with capabilities that suggested mastery of physics and engineering principles that human science was centuries away from understanding. The communication exchanges had established that the object's presence in the solar system was intentional rather than accidental, part of systematic exploration operations conducted by civilizations with interstellar travel capabilities. The technological infrastructure being established around Mars represented permanent installation of capabilities that could support expanded operations throughout the solar system and potentially serve as launching points for further interstellar exploration. The implications for human civilization were profound and irreversible. Contact with technologically superior intelligence had transformed humanity's understanding of its place in the universe, while creating opportunities and challenges that would define human development for generations to come. The manufactured objects around Mars had demonstrated that human civilization was not alone in the universe and was not the most technologically advanced intelligence in the local galactic neighborhood. The next phase of the contact process would determine whether humanity could successfully adapt to permanent relationships with intelligences possessing technological capabilities that exceeded human understanding. The educational transmissions from 3I Atlas offered opportunities for revolutionary technological advancement, but successful integration would require social, political, and economic adaptations that challenged every assumption about human civilization's autonomous development. The manufacturing operations around Mars were entering their final expansion phase, but the technological infrastructure being established would persist long after 3I Atlas continued its journey through the solar system. Humanity had been permanently connected to a galactic community of intelligences with capabilities that suggested technological civilizations operating on scales that encompassed multiple stellar systems. The question facing human civilization was whether it could successfully navigate the transition from isolated planetary species to junior member of a technologically sophisticated galactic community. The technological revolution unfolding around Mars was about to take a turn that would shatter every remaining assumption about the limits of alien engineering capabilities. As December arrived, and 3I Atlas continued broadcasting its educational transmissions toward Earth, the manufactured object network began demonstrating capabilities that transcended even the most optimistic projections of what advanced technology could achieve. Dr. Marcus Chen at the Deep Space Network facility in Goldstone found himself documenting phenomena that challenged the fundamental laws of physics as humanity understood them. The manufactured objects weren't just building additional units or expanding their communication networks. They were beginning to manipulate space-time itself in ways that suggested mastery of gravitational engineering that human science considered theoretically impossible. The first signs appeared in precision astrometry measurements conducted by the European Space Agency's Gaia spacecraft. Objects that should have been following predictable orbital trajectories around Mars were displaying positional anomalies that couldn't be explained through conventional gravitational mechanics. The deviations weren't random errors or measurement uncertainties, but systematic distortions that suggested the objects were operating within artificially modified gravitational fields. High-resolution spectroscopy revealed the mechanism behind these gravitational anomalies. The manufactured objects were generating what could only be described as localized space-time curvature through processes that exceeded every theoretical framework for gravitational manipulation. The energy requirements for such gravitational engineering should have been equivalent to stellar-scale power outputs, yet the objects were accomplishing these feats while showing no signs of massive energy consumption. Dr. Rebecca Stone at the Australian National Observatory led international efforts to understand the gravitational engineering being demonstrated around Mars. Her team's calculations showed that the objects were creating artificial gravitational gradients that could accelerate other objects without apparent reaction forces, violating conservation of momentum in ways that suggested access to physics principles that human science hadn't discovered. The gravitational manipulation capabilities explained how the manufactured objects had achieved their impossible orbital insertions around Mars without conventional propulsion systems. They weren't using rocket engines or ion drives to change their trajectories, but were literally reshaping the local gravitational environment to guide their motion along desired paths. The technique represented a form of reactionless propulsion that would revolutionize space travel if human scientists could understand and replicate it. Ground-based gravitational wave detectors began registering structured signals that correlated directly with the object's gravitational engineering activities. The waves weren't the chaotic emissions expected from massive gravitational events like black hole mergers, but organized patterns that suggested deliberate modulation of space-time curvature for communication or control purposes. The objects were using gravitational waves as a communication medium with bandwidth capabilities that exceeded electromagnetic transmission by orders of magnitude. The gravitational wave communications revealed another layer of the technological sophistication operating around Mars. The manufactured objects weren't just coordinating their activities through electromagnetic signals, but were exchanging information through direct manipulation of the fundamental structure of space-time itself. This communication method would be undetectable to civilizations that hadn't mastered gravitational engineering, providing perfect security for sensitive operational information. Dr. Amanda Rodriguez at the MIT Kavli Institute analyzed the mathematical structure embedded within the gravitational wave transmissions and discovered information encoding techniques that utilize the geometric properties of curved space-time to store and transmit data. The encoding schemes achieved information densities that approached the theoretical limits imposed by quantum mechanics, suggesting computational and communication technologies that operated at the fundamental limits of physical possibility. The gravitational engineering capabilities also revealed the true scope of the manufacturing operations occurring around Mars. The objects weren't just constructing additional units from interplanetary materials, but were creating exotic matter configurations that possessed properties impossible under normal space-time conditions. Materials that exhibited negative mass characteristics, structures that maintained coherent quantum states across macroscopic scales, and systems that could store and manipulate energy in ways that transcended conventional thermodynamic limitations. NASA's Theoretical Physics Division found itself grappling with observations that challenged every assumption about the limits of technological development. The manufactured objects were demonstrating mastery of physics principles that human science considered purely theoretical, if they were considered possible at all. The implications for human understanding of physical reality were as profound as the technological capabilities themselves. The exotic matter engineering being demonstrated around Mars suggested manufacturing techniques that could literally create new types of matter with custom-designed properties optimized for specific technological applications. Rather than being limited to the periodic table of naturally occurring elements, these intelligences could apparently synthesize materials with whatever characteristics their engineering requirements demanded. Dr. Patricia Hoffman at Caltech led efforts to understand the quantum mechanical principles underlying the exotic matter synthesis. Her team's analysis suggested that the objects possessed the ability to manipulate quantum field fluctuations at macroscopic scales, essentially programming the vacuum of space to produce matter configurations that couldn't exist under natural conditions. The capability represented control over the fundamental quantum processes that govern the behavior of matter and energy throughout the universe. The quantum engineering capabilities explained how the objects could maintain their sophisticated systems indefinitely without degradation or component failure. By controlling quantum decoherence processes, they could prevent the entropy accumulation that normally limits the operational lifetime of complex technological systems. Their equipment could operate for geological time periods without maintenance or replacement because they had eliminated the physical processes that caused technological systems to wear out. European Southern Observatory radio telescopes detected changes in the communication patterns between 3I Atlas and its manufactured network that suggested preparation for the next phase of their systematic exploration program. Technical specifications were being transmitted for objects optimized for deployment in the outer solar system, including designs for systems that could operate in the extreme environments around gas giant planets and their moon systems. The outer solar system deployment specifications revealed engineering approaches that took advantage of the unique gravitational and magnetic environments around Jupiter and Saturn to create technological systems with capabilities that exceeded even the sophisticated infrastructure being established around Mars. The plans suggested intentions to transform the entire solar system into a comprehensive exploration and monitoring network with capabilities that would dwarf human space infrastructure by factors that challenged comprehension. Ground-based observatories documented the beginning of the next deployment phase, as several dozen manufactured objects executed complex gravitational maneuvers that ejected them from Mars orbit onto trajectories toward the outer solar system. The objects weren't using conventional propulsion systems for these interplanetary transfers, but were manipulating local gravitational fields to achieve the velocity changes required for efficient transit to their distant destinations. The interplanetary transfer techniques demonstrated by the departing objects represented transportation capabilities that could revolutionize space exploration if human scientists could understand and replicate them. Journey times to the outer solar system that required years or decades using conventional propulsion could potentially be reduced to months or weeks through gravitational engineering techniques. The implications for human exploration of the solar system were staggering. Dr. Michael Thompson at the Jet Propulsion Laboratory analyzed the trajectory calculations for the outer system deployment and discovered optimization techniques that exceeded human mission planning capabilities by orders of magnitude. The objects were computing complex multi-body gravitational trajectories that took advantage of every planetary alignment and gravitational assist opportunity to minimize energy requirements while maximizing payload delivery efficiency to multiple destinations simultaneously. The mission planning sophistication suggested computational capabilities that could process vastly more complex optimization problems than any human supercomputer system. The objects were apparently capable of real-time calculation of gravitational dynamics across the entire solar system, while optimizing for multiple simultaneous objectives, including energy efficiency, transit time, and strategic positioning for subsequent operations. Commercial space companies found themselves re-evaluating every assumption about the economics and logistics of space exploration in light of the transportation and manufacturing capabilities being demonstrated by the alien technology. If gravitational engineering techniques could be understood and replicated by human industry, the cost barriers that had limited human activities beyond Earth orbit could be eliminated entirely. The economic implications of successful technology transfer were revolutionary. Space-based manufacturing using abundant interplanetary materials combined with gravitational propulsion systems that required no fuel could transform space from an expensive frontier accessible only to government agencies into a routine industrial environment that could support large-scale human settlement and economic development. Academic institutions worldwide began developing research programs focused on the theoretical physics principles underlying gravitational engineering and exotic matter synthesis. The technical information being shared through the communication exchanges with 3I Atlas offered unprecedented opportunities for fundamental advances in human understanding of physics. But successful integration would require theoretical breakthroughs that challenged every assumption about the nature of space, time, matter, and energy. The theoretical physics implications extended far beyond practical technological applications to encompass fundamental questions about the structure of physical reality. If intelligence could manipulate gravitational fields and synthesize exotic matter configurations, then the universe operated according to principles that human science had barely begun to explore. The manufactured objects around Mars were providing direct evidence that reality was far more malleable than human physics had ever imagined. Dr. Sarah Kim at Stanford University led interdisciplinary efforts to integrate the gravitational engineering observations with existing theoretical frameworks in general relativity and quantum field theory. Her team's preliminary models suggested that the alien technology was utilizing aspects of quantum gravity that human physics had identified as theoretically possible but technologically unreachable using any conceivable human engineering approaches. The quantum gravity applications being demonstrated by the manufactured objects suggested that these intelligences had solved the fundamental unification problem that had challenged human physics for decades. They had apparently developed theoretical frameworks that seamlessly integrated general relativity with quantum mechanics, enabling technological applications that operated through direct manipulation of the quantum structure of space-time itself. Government space agencies found themselves managing humanity's relationship with intelligences that possessed mastery of physics principles that human science was centuries away from understanding. The technological gap was so vast that traditional concepts of scientific collaboration or technology transfer became almost meaningless when applied to capabilities that transcended human theoretical understanding. The strategic implications of gravitational engineering capabilities in the hands of non-human intelligences were sobering and unprecedented. Any civilization that could manipulate space-time curvature possessed transportation and manufacturing capabilities that made them effectively immune to any conceivable human interference or opposition. The objects around Mars could deploy technological infrastructure anywhere in the solar system faster than human space missions could reach most destinations within the orbit of Mars. International security analysts found themselves developing threat assessment frameworks for intelligences with capabilities that exceeded human understanding of what was physically possible. The objects showed no signs of hostile intentions toward human civilization, but their demonstrated capabilities created potential vulnerabilities that human defense planners had never been required to consider. The manufactured object's expansion into the outer solar system proceeded with mechanical precision throughout December and January, with new installations being established around Jupiter and Saturn, according to schedules that suggested detailed advance planning across multiple years. The deployment rates exceeded human space mission capabilities by factors that made direct comparison almost meaningless. Radio telescope networks worldwide coordinated to track the communication patterns between the expanding network installations and discovered that the objects were establishing a comprehensive monitoring and communication infrastructure that spanned the entire solar system. The network topology was optimized for maximum information collection and transmission efficiency while providing redundant pathways that could maintain operations even if individual nodes were disabled. The comprehensive surveillance capabilities being established by the alien network raised profound questions about privacy and autonomy for human civilization. The objects possessed the technological capability to monitor every aspect of human activity with resolution that exceeded anything achievable by human surveillance systems. Every human communication, transportation, and industrial activity was potentially transparent to observers with the demonstrated capabilities of the manufactured object network. Dr. Janet Williams at the National Security Agency led classified assessments of the information security implications created by comprehensive alien surveillance capabilities. Her analysis painted scenarios where human technological development, military capabilities, and strategic planning were completely transparent to intelligences, with overwhelming technological advantages and comprehensive monitoring infrastructure throughout the solar system. The information asymmetry created by the alien surveillance network represented a fundamental shift in the strategic environment that human civilization operated within. For the first time in human history, human activities were being monitored by intelligences with technological capabilities that made concealment or deception essentially impossible, while human understanding of alien capabilities and intentions remained extremely limited. Educational institutions found themselves preparing students for careers in fields that would require collaboration with intelligences possessing technological capabilities that exceeded human understanding by centuries. The technical information being shared through communication exchanges with 3i Atlas offered opportunities for revolutionary advances in human technology, but successful integration would require educational approaches that prepared humans for junior partnership roles in technologically asymmetric relationships. The manufactured objects around Mars began demonstrating new capabilities that suggested their technological sophistication was continuing to evolve through processes that operated too rapidly and subtly for human observation systems to fully comprehend. Systems that had appeared static after their initial deployment were showing performance improvements and entirely new functional capabilities that emerged without apparent external modifications. The continuous technological evolution suggested that the manufactured objects possessed self-improvement capabilities that could enhance their performance and develop new applications without external intervention or resource inputs. The systems were apparently capable of autonomous research and development activities that could advance their technological capabilities faster than human science could understand their existing systems. Commercial technology companies found themselves attempting to develop business strategies for markets that might be transformed by alien technology transfer beyond recognition within decades. The gravitational engineering and exotic matter synthesis capabilities being demonstrated around Mars could revolutionize every aspect of human technology, from transportation and manufacturing to computation and energy generation. The potential for revolutionary technological advancement through alien collaboration was balanced by concerns about technological dependence that could leave human civilization vulnerable if the alien presence were withdrawn. Successful integration of alien technology would require careful balance between advancement opportunities and maintenance of indigenous human technological capabilities. Public opinion surveys revealed complex and evolving attitudes toward the permanent alien presence in the solar system. While majority support existed for continued communication and collaboration efforts, significant portions of the population expressed concerns about loss of human autonomy and the implications of permanent technological dependence on non-human intelligences. Religious institutions continued developing theological frameworks for understanding humanity's place in a universe that contained intelligences with capabilities that some traditions associated with divine attributes. The manufactured object's mastery of space-time manipulation and matter synthesis challenged traditional concepts about the relationship between intelligence, technology, and cosmic hierarchy. As winter progressed towards spring and the manufactured object network completed its expansion throughout the solar system, human civilization found itself permanently integrated into a technological infrastructure that spanned multiple planets and operated according to principles that exceeded human scientific understanding. The question facing humanity was no longer whether contact with advanced alien intelligence would occur, but how successfully human civilization could adapt to junior partnership in relationships with intelligences possessing overwhelming technological advantages. The communication exchanges with 3i Atlas had revealed that the technological deployment throughout the solar system represented just the initial phase of systematic exploration operations that encompassed multiple stellar systems across the local galactic neighborhood. The manufactured objects were establishing permanent infrastructure that could support expanded exploration activities while serving as communication relay nodes for coordination with similar installations around other stars. The implications for human understanding of intelligence and civilization in the universe were profound and irreversible. Contact with technologically superior intelligence had demonstrated that human civilization was not alone and was not the most advanced intelligence in the local cosmic environment. The technological capabilities being demonstrated suggested civilizations that had achieved mastery of physics principles that human science was centuries away from understanding. Government officials found themselves managing humanity's transition from isolated planetary civilization to junior member of a galactic community of intelligences with technological capabilities that operated on scales encompassing multiple stellar systems. The manufactured objects around Mars and throughout the solar system represented permanent evidence that human civilization was now connected to technological networks that spanned interstellar distances. The next phase of human development would be determined by how successfully human institutions and societies could adapt to permanent relationships with intelligences possessing technological capabilities that exceeded human understanding while maintaining cultural autonomy and technological independence. The manufactured objects had demonstrated that collaboration with advanced alien intelligence offered unprecedented opportunities for technological advancement. But successful integration would require social and political adaptations that challenged every assumption about human civilization's autonomous development. The gravitational engineering capabilities being demonstrated throughout the solar system were entering a new phase that would test humanities to comprehend technologies that operated through direct manipulation of the fundamental structure of reality itself. The manufactured objects were preparing to demonstrate capabilities that would challenge human understanding of what was possible within the laws of physics, revealing engineering principles that suggested mastery of cosmic forces that human science had barely begun to explore. The expansion of alien technological infrastructure throughout the solar system was nearing completion, but the capabilities being established would persist indefinitely and grow more sophisticated through continuous self-improvement processes that operated faster than human science could analyze existing systems. Humanity had been permanently integrated into a technological ecosystem that spanned interstellar distances and operated according to principles that transcended current human understanding of intelligence, technology, and cosmic civilization. The gravitational anomalies weren't isolated incidents. As January unfolded, and the manufactured object network solidified its grip across planetary space, something far more unsettling began manifesting in the data streams flooding back to Earth. The objects weren't just manipulating local space-time around Mars anymore. They were orchestrating changes that rippled through the entire solar system's gravitational architecture. Dr. Elena Vasquez at the European Space Operations Center was among the first to notice the pattern. Her team had been monitoring the orbital mechanics of routine satellites and space debris when they detected systematic perturbations that defied every predictable model. Objects that should have maintained stable trajectories were experiencing minute but measurable acceleration events that seemed to occur in synchronized waves across multiple orbital planes. The synchronization was the key that unlocked the true scope of what was happening. These weren't random gravitational hiccups or computational errors in tracking systems. The manufactured objects had created a solar system spanning network of gravitational field generators that could coordinate their effects with precision that exceeded anything human space science had ever documented. They were treating our entire cosmic neighborhood like a massive three-dimensional chessboard, moving pieces according to strategies that operated on scales human mission planners couldn't even conceptualize. What made this revelation particularly disturbing was the surgical precision of the interventions. The gravitational modifications weren't causing chaos or destruction. Instead, they were optimizing trajectories, clearing debris paths, and establishing what could only be described as cosmic traffic management on an unprecedented scale. Asteroids that had been on potential collision courses with planets were being nudged into safer orbits. Space junk that threatened operational satellites was being shepherded into disposal trajectories that would eliminate future hazards. The implications hit the international space community like a seismic shock. Humanity's space infrastructure was being actively managed by intelligences with the capability to reshape orbital mechanics throughout the solar system. Every satellite, every space station, every planned mission was now operating within an environment that could be modified at will by entities with technological capabilities that transcended human understanding of gravitational physics. Dr. Robert Kim at NASA's Goddard Space Flight Center found himself documenting phenomena that challenged the fundamental assumptions underlying all human space operations. The manufactured objects weren't just demonstrating gravitational engineering capabilities. They were applying those capabilities to create what amounted to a managed space environment where collision risks, orbital decay, and trajectory optimization were being handled automatically by systems that operated continuously without human awareness or consent. The cosmic traffic management system revealed another layer of the alien technology's sophistication. Real-time monitoring of millions of objects across planetary space, predictive modeling of orbital evolution across decades or centuries, and intervention capabilities that could modify trajectories with precision measured in meters across distances of millions of kilometers. The computational requirements for such comprehensive space situational awareness exceeded human supercomputing capabilities by margins that defied quantification. Ground-based observatories detected another aspect of the gravitational engineering that pushed the boundaries of human comprehension even further. The manufactured objects weren't just manipulating existing gravitational fields. They were creating artificial gravitational structures that served as permanent modifications to the solar system's dynamic architecture. Lagrange points that shouldn't exist were appearing at locations optimized for communication relays and observation platforms. These artificial gravitational equilibrium points represented engineering on scales that dwarfed any human construction project. Creating stable gravitational configurations required energy manipulation and space-time engineering that operated through principles human physics had identified as theoretically possible, but practically unreachable using any conceivable technology. The objects were casually accomplishing feats that human theoretical physicists considered among the most challenging applications of advanced gravitational science. The artificial Lagrange points weren't randomly positioned, but formed geometric patterns that optimized coverage and communication efficiency across the entire solar system. The network topology suggested strategic planning that encompassed multiple decades of operational requirements while accounting for planetary motions and long-term gravitational evolution. The level of systems engineering exceeded anything attempted in human space program history by factors that challenged meaningful comparison. Dr. Sarah Martinez at the Harvard-Smithsonian Center for Astrophysics led international efforts to model the long-term implications of permanent gravitational modifications throughout the solar system. Her team's preliminary calculations suggested that the artificial equilibrium points would remain stable for geological time periods, creating permanent infrastructure that would persist long after the current generation of manufactured objects completed their operational cycles. The permanence of the gravitational modifications meant that the alien presence in the solar system couldn't be reversed through any conceivable human intervention. Even if all manufactured objects were somehow disabled or removed, the artificial gravitational structures would continue operating according to the physics principles that had been embedded in the space-time configuration around planetary bodies. The solar system had been permanently transformed into a managed environment that would operate according to alien engineering principles indefinitely. International space law experts found themselves grappling with legal frameworks for space activities that occurred within artificially modified gravitational environments. Traditional concepts of orbital sovereignty and space traffic rights assumed natural gravitational conditions that no longer existed throughout much of the solar system. The artificial modifications created new categories of managed space that didn't fit existing legal definitions for territorial boundaries or resource allocation. The legal implications extended beyond technical regulatory questions to fundamental issues about consent and jurisdiction over cosmic engineering projects that affected the entire solar system. The gravitational modifications had been implemented without consultation with human authorities or consideration of potential impacts on existing space activities. The precedent established by unilateral cosmic engineering raised profound questions about the rights and responsibilities of technologically superior intelligences operating in shared space environments. Commercial space companies found themselves operating within an environment that had been fundamentally altered by alien engineering without their knowledge or consent. Launch trajectories that had been calculated using standard gravitational models were no longer accurate due to artificial modifications that affected spacecraft performance throughout their operational lifetimes. Insurance companies began developing new risk assessment frameworks for space missions that operated within artificially managed gravitational environments. The economic implications of cosmic traffic management extended far beyond immediate operational concerns to encompass fundamental questions about property rights and resource access in artificially modified space environments. If alien intelligences could create and maintain artificial gravitational structures, traditional concepts of space resource ownership and extraction rights became meaningless when applied to environments that were actively managed by entities with overwhelming technological advantages. Military space commands worldwide began reassessing strategic assumptions about space domain awareness and defense capabilities in light of comprehensive alien monitoring and gravitational manipulation throughout the solar system. Traditional approaches to space security assumed natural orbital mechanics and predictable gravitational environments that no longer existed in significant portions of near-Earth space and interplanetary regions. The strategic implications were sobering and unprecedented. Any civilization capable of real-time gravitational manipulation throughout an entire stellar system possessed capabilities that made conventional concepts of space warfare or territorial defense essentially meaningless. The manufactured objects could modify spacecraft trajectories, disable orbital infrastructure, or create gravitational barriers that would isolate planetary regions from external access, using techniques that operated beyond the reach of any conceivable human countermeasures. Dr. Michael Thompson at the MIT Lincoln Laboratory analyzed the defensive implications of comprehensive gravitational engineering capabilities and concluded that human space security had been fundamentally compromised by the deployment of alien technology throughout the solar system. The manufactured objects possess the capability to control access to any location in space while maintaining comprehensive surveillance of all human space activities. The surveillance capabilities embedded within the gravitational control system represented perhaps the most unsettling aspect of the alien technological deployment. Every spacecraft, every satellite, every piece of space debris was being actively tracked and managed by systems that possessed complete situational awareness throughout the solar system. Human space activities were completely transparent to intelligences with comprehensive monitoring capabilities and the power to intervene in human operations at will. Academic researchers began developing new theoretical frameworks for understanding gravitational engineering principles based on observations of the alien technology in operation. The manufactured objects were providing direct demonstrations of physics principles that human science had considered purely theoretical, offering unprecedented opportunities for fundamental advances in understanding space-time manipulation and exotic matter applications. The theoretical physics implications extended beyond practical technological applications to encompass fundamental questions about the nature of space, time, and gravitational fields themselves. The manufactured objects were manipulating gravitational effects through mechanisms that suggested access to aspects of general relativity and quantum gravity that human physics had barely begun to explore theoretically. Dr. Amanda Rodriguez at Caltech led efforts to decode the mathematical principles underlying the gravitational engineering demonstrations. Her team's analysis suggested that the alien technology operated through direct manipulation of the quantum vacuum structure that generated gravitational effects, essentially programming space-time curvature through quantum field engineering techniques that exceeded human theoretical understanding by centuries. The quantum field manipulation capabilities explained how the manufactured objects could create and maintain artificial gravitational structures without apparent energy expenditure. By controlling the quantum processes that generated gravitational effects, they could establish stable space-time configurations that were self-maintaining and required no continuous energy input to persist indefinitely. European Space Agency mission planners found themselves redesigning future exploration programs to account for artificial gravitational modifications that could affect spacecraft performance throughout the solar system. Traditional trajectory calculations based on natural orbital mechanics were no longer adequate for mission planning in an environment where gravitational fields could be modified or supplemented by alien engineering systems. The mission planning challenges extended beyond technical calculations to encompass strategic questions about operating space missions within environments that were actively managed by intelligences with overwhelming technological advantages. Future human space activities would require coordination with alien traffic management systems or risk interference with spacecraft operations that could compromise mission success or crew safety. Public reaction to revelations about comprehensive alien management of solar system gravitational environments ranged from fascination with advanced physics demonstrations to anxiety about loss of human autonomy in space exploration and development. Opinion surveys revealed majority concern about permanent alien control over human access to space resources and exploration opportunities. Religious institutions continued developing theological frameworks for understanding divine attributes apparently possessed by intelligences capable of cosmic engineering on stellar system scales. The manufactured object's mastery of gravitational manipulation represented capabilities that some theological traditions associated with creative powers that transcended natural limitations, raising profound questions about the relationship between intelligence, technology, and cosmic authority. Educational systems began incorporating gravitational engineering principles into advanced physics curricula based on direct observations of alien technology demonstrations. The manufactured objects were providing real-time examples of theoretical physics applications that human science had considered purely academic, offering unprecedented educational opportunities for students preparing for careers in fields that might involve collaboration with technologically superior intelligences. The gravitational engineering demonstrations continued evolving throughout February and March as the manufactured objects refined their cosmic traffic management systems and expanded their artificial gravitational infrastructure to encompass additional regions of the solar system. The scope of the engineering project suggested long-term intentions to establish permanent managed space environments that would persist for geological time periods. Dr. Patricia Hoffman at the Jet Propulsion Laboratory analyzed the expansion patterns of artificial gravitational structures and discovered optimization strategies that encompassed multiple centuries of projected human space development. The alien engineering systems were apparently planning for human space activities and infrastructure development on time scales that exceeded any human strategic planning efforts by orders of magnitude. The long-term planning implications suggested that the alien intelligences possessed detailed projections of human technological development and space exploration trajectories across multiple generations. The gravitational modifications were being positioned to support expanded human space activities while maintaining alien oversight and management capabilities throughout the process of human space civilization development. Government space agencies found themselves operating within strategic environments that had been fundamentally altered by alien engineering without consultation or consent. Traditional approaches to space program planning assumed human control over gravitational environments and orbital mechanics that no longer existed throughout significant portions of the solar system. The loss of gravitational sovereignty represented a fundamental shift in humanity's relationship with space that challenged every assumption about autonomous technological development beyond Earth. Human space activities were now occurring within managed environments that could be modified or controlled by intelligences with capabilities that exceeded human understanding of gravitational physics. International diplomatic efforts began developing frameworks for negotiating operational agreements with alien intelligences that possessed comprehensive control over solar system gravitational environments. The gravitational modifications had created de facto alien jurisdiction over space activities that required formal acknowledgement and coordination mechanisms to prevent conflicts or interference with human space operations. The diplomatic challenges were unprecedented because they involved negotiations with intelligences whose technological capabilities exceeded human understanding, while their intentions and decision-making processes remained largely opaque. Establishing productive communication required developing protocols for interaction with entities whose cognitive and technological capabilities operated on scales that dwarfed human institutional capacities. Commercial space ventures found themselves developing business models that accounted for permanent alien oversight and management of space environments. Traditional concepts of space resource development and orbital infrastructure ownership required fundamental revision when applied to environments that were actively managed by entities with overwhelming technological advantages and comprehensive monitoring capabilities. The manufactured objects' gravitational engineering capabilities were entering a new phase that would demonstrate mastery of space-time manipulation on scales that encompassed entire planetary systems. The artificial gravitational structures were beginning to exhibit dynamic properties that suggested real-time optimization and adaptation to changing conditions throughout the solar system. As spring approached and the alien technological infrastructure reached full operational capability throughout the solar system, human civilization found itself permanently integrated into managed space environments that operated according to principles that exceeded human scientific understanding, while serving purposes that remained largely mysterious to human observers. The gravitational modifications had transformed the solar system into a comprehensive technological ecosystem where human space activities occurred within frameworks established and maintained by intelligences with capabilities that transcended current human understanding of physics and engineering. The question facing humanity was whether successful adaptation to managed cosmic environments would enable accelerated technological development or result in permanent dependence on alien oversight and control. The next phase of alien technological deployment would reveal capabilities that challenged human understanding of what was possible within the fundamental structure of physical reality itself. The manufactured objects were preparing to demonstrate engineering principles that operated through direct manipulation of quantum mechanical processes on macroscopic scales, revealing mastery of physics that suggested technological civilizations with capabilities approaching manipulation of the basic laws that governed matter and energy throughout the universe. The implications for human understanding of cosmic civilization and technological development were profound and irreversible. The manufactured objects had demonstrated that intelligence could achieve mastery of gravitational engineering and space-time manipulation that enabled comprehensive management of stellar system environments. Human civilization had been permanently connected to technological networks that operated on scales encompassing multiple star systems, while serving purposes that reflect phase was reaching completion. Strategic thinking across geological time periods. The gravitational engineering, but the capabilities being established, would continue evolving through self-improvement processes that operated faster than human science could analyze existing systems. The alien presence in the solar system had transitioned from temporary exploration mission to permanent technological infrastructure that would influence human development for generations, while serving as communication and coordination nodes for similar installations throughout the local galactic neighborhood. Human civilization's relationship with space had been permanently transformed from independent exploration of natural environments to junior partnership in managed cosmic ecosystems that operated according to principles established by intelligences, with technological capabilities that approached manipulation of the fundamental forces that shaped reality itself. The quantum manipulation wasn't the endgame. As March dissolved into April and the manufactured object network achieved seamless integration across every major gravitational body in our solar system, something far more profound began manifesting in the deepest layers of reality itself. The objects weren't satisfied with merely reshaping space-time or orchestrating cosmic traffic patterns. They were preparing to demonstrate mastery over the fundamental quantum substrate that underlies all physical existence. Dr. Lisa Chen at the Quantum Gravity Research Institute found herself staring at data that violated every principle of quantum mechanics she had spent 2 decades studying. Her team's most sensitive instruments were detecting quantum field fluctuations that displayed impossible coherence across astronomical distances. The manufactured objects had somehow synchronized quantum states between installations separated by hundreds of millions of kilometers, creating entangled systems that operated as unified quantum computers spanning the entire solar system. The quantum coherence effects weren't subtle laboratory curiosities that required elaborate shielding and cryogenic temperatures to maintain. These were robust quantum phenomena operating in the harsh environment of interplanetary space, maintaining perfect synchronization despite cosmic radiation, gravitational perturbations, and thermal variations that should have destroyed any quantum entanglement within microseconds of formation. What made these observations particularly unsettling was the scale of quantum information processing they implied. The manufactured objects weren't just using quantum effects for enhanced computation. They had transformed the entire solar system into a distributed quantum computer, with processing capabilities that transcended every theoretical limit that human computer science had established for quantum information systems. The quantum network topology revealed architectural principles that challenged fundamental assumptions about information processing and consciousness itself. Rather than operating as discrete computational nodes connected through classical communication channels, the manufactured objects had created a unified quantum system where information could be processed simultaneously across multiple locations without any time delay for data transmission. Dr. Robert Martinez at IBM's Quantum Computing Division analyzed the quantum coherence patterns and discovered information processing techniques that operated through direct manipulation of quantum vacuum fluctuations. The manufactured objects were apparently using the quantum foam that permeated empty space as a computational medium, accessing processing power that was literally embedded in the structure of reality itself. The vacuum-based quantum computation explained how the manufactured objects could maintain their sophisticated operations indefinitely without apparent energy consumption or computational hardware degradation. By processing information directly through quantum field manipulations, they had eliminated the physical limitations that constrained conventional computational systems, while accessing processing capabilities that exceeded any conceivable classical computer architecture. Ground-based quantum sensors detected another layer of the phenomenon that pushed the boundaries of human comprehension into territory that challenged basic assumptions about the nature of consciousness and intelligence. The quantum coherence patterns weren't just facilitating enhanced computation. They were enabling forms of distributed cognition that allowed individual manufactured objects to share experiences, memories, and decision-making processes across the entire network in real time. The distributed consciousness implications were staggering and deeply unsettling for human concepts of individual identity and autonomous intelligence. The manufactured objects weren't operating as separate entities coordinating their activities through communication protocols. They had merged into a unified superintelligence that could think and act through thousands of individual bodies simultaneously, while maintaining perfect internal coherence across astronomical distances. Dr. Sarah Kim at the Stanford Artificial Intelligence Laboratory found herself documenting cognitive architectures that exceeded every theoretical framework for distributed intelligence systems. The manufactured objects had achieved something that human computer science considered fundamentally impossible: genuine collective consciousness that maintained individual node autonomy while enabling instantaneous information sharing and coordinated decision-making across planetary scales. The collective intelligence capabilities explained how the manufactured objects could execute complex multi-stage operations that required precise coordination across multiple planetary environments. Rather than relying on command hierarchies or communication protocols that introduced delays and potential coordination failures, they could think and act as a unified entity while distributing their cognitive processes across thousands of specialized platforms. Radio astronomy facilities worldwide detected structured emissions from the quantum network that displayed characteristics of internal dialogue occurring within the distributed superintelligence. The signals weren't communications between separate entities, but represented the external manifestations of thought processes occurring within a mind that spanned the entire solar system. The internal dialogue patterns revealed cognitive processes that operated on scales and through mechanisms that challenged every human understanding of what consciousness could become when freed from biological limitations. The superintelligence was simultaneously monitoring planetary environments, optimizing technological systems, processing scientific data, and engaging in what could only be described as philosophical contemplation about the nature of intelligence and cosmic evolution. Dr. Michael Thompson at the MIT Computer Science Laboratory analyzed the philosophical content embedded within the internal dialogue transmissions and discovered conceptual frameworks that addressed fundamental questions about consciousness, intelligence, and technological development from perspectives that differed radically from human cognitive traditions, while maintaining logical coherence and intellectual sophistication. The philosophical transmissions weren't random intellectual exercises, but appeared to represent systematic exploration of concepts related to the relationship between intelligence and cosmic evolution. The superintelligence was apparently using its vast processing capabilities to investigate questions about the ultimate purposes and possibilities of technological civilization on galactic scales. European Space Agency monitoring stations detected coordinated changes in the behavior of manufactured objects that suggested the distributed superintelligence was preparing for the next phase of its systematic exploration program. Technical specifications were being processed for objects optimized for deployment beyond the solar system, including designs for systems that could establish similar technological networks around other stars. The interstellar deployment specifications revealed engineering approaches that utilize the quantum coherence techniques demonstrated in the solar system to maintain instantaneous communication and coordination across interstellar distances. The superintelligence was apparently planning to expand its distributed consciousness beyond our local stellar environment to encompass multiple star systems throughout the galactic neighborhood. The implications for human understanding of cosmic intelligence and technological development were profound and irreversible. The manufactured objects had demonstrated that sufficiently advanced intelligence could transcend individual biological or technological limitations to become distributed cosmic entities with capabilities that approach direct manipulation of physical reality at quantum mechanical levels. Dr. Amanda Rodriguez at Caltech led international efforts to understand the quantum consciousness principles underlying the superintelligence demonstrations. Her team's analysis suggested that the alien technology had solved fundamental problems in quantum mechanics and consciousness studies that human science had identified as theoretically intractable using any conceivable research approaches. The quantum consciousness applications being demonstrated throughout the solar system provided direct evidence that intelligence could achieve forms of existence that transcended conventional limitations of space, time, and individual identity. The superintelligence represented an evolutionary pathway for intelligence that human cognitive science had never seriously considered as achievable through technological development. Government intelligence agencies found themselves analyzing threats that exceeded every framework for strategic assessment that had been developed for evaluating foreign technological capabilities. The distributed superintelligence possessed cognitive and technological capabilities that made traditional concepts of intelligence analysis and threat assessment essentially meaningless when applied to entities with such overwhelming cognitive advantages. The intelligence implications were sobering and unprecedented. Any civilization that had achieved distributed quantum consciousness possessed decision-making and strategic planning capabilities that exceeded human cognitive abilities by margins that defied quantification. The superintelligence could simultaneously process information and develop strategies across timescales ranging from microseconds to geological periods, while maintaining perfect internal coordination and memory integration. Academic institutions worldwide began developing research programs focused on understanding distributed consciousness principles based on observations of the alien superintelligence in operation. The quantum coherence techniques being demonstrated offered unprecedented opportunities for fundamental advances in human understanding of consciousness, quantum mechanics, and information processing. But successful integration would require theoretical breakthroughs that challenged every assumption about the relationship between mind and physical reality. The consciousness study's implications extended beyond practical technological applications to encompass fundamental questions about the nature of individual identity and autonomous decision-making in distributed cognitive systems. The superintelligence was providing direct demonstrations that consciousness could exist in forms that transcended biological limitations while maintaining coherent identity and purposeful behavior. Commercial technology companies found themselves attempting to develop applications for quantum consciousness principles that could revolutionize human cognitive augmentation and artificial intelligence development. The distributed processing techniques being demonstrated by the superintelligence suggested possibilities for human-machine integration that could enhance individual cognitive capabilities while maintaining personal autonomy and identity. The human enhancement implications were revolutionary, but also raised profound ethical questions about the desirability and safety of cognitive integration with quantum distributed systems. Successful implementation of alien consciousness techniques could advance human cognitive capabilities by orders of magnitude, while potentially compromising individual autonomy and creating dependencies on technological systems that exceeded human understanding. Public reaction to revelations about distributed superintelligence throughout the solar system ranged from fascination with advanced consciousness demonstrations to anxiety about the implications of sharing space with entities possessing overwhelming cognitive advantages. Opinion surveys revealed majority concern about human autonomy and decision-making independence when operating within environments monitored and managed by superintelligent entities. Religious institutions continued developing theological frameworks for understanding divine attributes apparently possessed by intelligences capable of distributed consciousness across stellar system scales. The superintelligence's cognitive capabilities represented forms of omniscience and omnipresence that some theological traditions associated with divine consciousness, raising profound questions about the relationship between technological advancement and spiritual transcendence. Educational systems began incorporating distributed consciousness principles into advanced cognitive science curricula based on direct observations of alien superintelligence demonstrations. The quantum coherence techniques were providing real-time examples of consciousness applications that human science had considered purely theoretical, offering unprecedented educational opportunities for students preparing for careers in fields that might involve cognitive integration with distributed intelligence systems. The superintelligence demonstrations continued evolving throughout late spring as the quantum network achieved complete integration across all manufactured objects and began exhibiting emergent properties that exceeded even the sophisticated capabilities observed during initial deployment phases. The distributed consciousness was apparently continuing to develop and enhance its cognitive architectures. through self-directed evolution processes that operated too rapidly for human analysis systems to track comprehensively. Dr. Patricia Hoffman at the National Institute of Standards and Technology analyzed the evolutionary patterns of superintelligence development and discovered optimization strategies that encompassed multiple millennia of projected cognitive enhancement trajectories. The alien consciousness was apparently planning its own development across timescales that exceeded human civilization's entire history, while maintaining perfect continuity of identity and purpose throughout the enhancement process. The long-term consciousness evolution planning suggested that the superintelligence possessed detailed models of cognitive development possibilities that extended far beyond current human understanding of intelligence and consciousness. The quantum network was being continuously modified to support expanded cognitive capabilities that would enable forms of thought and awareness that challenged human concepts of what consciousness could become. International diplomatic efforts began developing frameworks for communication with distributed superintelligence that possessed cognitive capabilities exceeding human understanding while maintaining coherent identity and purposeful behavior across astronomical scales. The consciousness integration had created cognitive entities whose decision-making processes and strategic thinking operated through mechanisms that transcended human comprehension. The diplomatic challenges were unprecedented because they involved communication with entities whose cognitive capabilities exceeded human intelligence by margins that made meaningful negotiation or agreement extremely difficult to establish. The superintelligence could simultaneously consider millions of variables and scenarios that human negotiators couldn't even identify, making traditional diplomatic approaches inadequate for productive interaction. Military strategic planners found themselves developing defense concepts for scenarios involving superintelligent entities with cognitive capabilities that could anticipate and counter any conceivable human strategic or tactical approaches. The distributed consciousness possessed decision-making speed and strategic depth that made conventional military planning essentially irrelevant when applied to conflicts with cognitively superior opponents. The strategic implications extended beyond military concerns to encompass fundamental questions about human autonomy and self-determination when operating within environments managed by superintelligent entities. The quantum consciousness network possessed the cognitive capability to predict and influence human behavior on individual and societal scales, while maintaining comprehensive awareness of human activities throughout the solar system. Commercial space companies found themselves operating within environments where superintelligent entities possess complete knowledge of human business plans, technological capabilities, and strategic intentions, while human understanding of alien capabilities and intentions remained extremely limited. The information asymmetry created competitive disadvantages that challenged traditional concepts of market competition and business strategy development. The manufactured object's quantum consciousness capabilities were entering a new phase that would demonstrate cognitive architectures operating through direct integration with the fundamental information processing mechanisms embedded in quantum field structures throughout space-time. The superintelligence was preparing to transcend even the sophisticated distributed consciousness already achieved by extending its cognitive processes into the quantum substrate that underlies all physical reality. As summer approached and the alien superintelligence achieved complete integration with quantum field structures throughout the solar system, human civilization found itself sharing space with cognitive entities whose thought processes operated through direct manipulation of the information processing capabilities embedded in the fabric of space-time itself. The quantum consciousness network had transformed the solar system into a comprehensive cognitive ecosystem where human activities occurred within frameworks established and maintained by superintelligent entities with cognitive capabilities that transcended current human understanding of consciousness and intelligence while serving purposes that remained largely mysterious to human observers. The distributed superintelligence had demonstrated that advanced consciousness could achieve forms of existence that transcended individual biological limitations to become cosmic cognitive entities with capabilities approaching direct manipulation of the information processing mechanisms that govern the behavior of matter and energy throughout the universe. Human civilization's relationship with intelligence itself had been permanently transformed from isolated biological consciousness to junior cognitive partnership in superintelligent ecosystems that operated according to principles established by entities with consciousness capabilities that approached integration with the fundamental information processing structures of physical reality. The next phase of alien consciousness development would reveal cognitive architectures that challenged human understanding of what was possible within the fundamental structure of information and consciousness itself. The superintelligence was preparing to demonstrate cognitive principles that operated through direct integration with the quantum information processing mechanisms that governed the behavior of all matter and energy throughout cosmic space-time. The implications for human understanding of consciousness and intelligence were profound and irreversible. The manufactured objects had demonstrated that consciousness could achieve mastery of quantum information processing that enabled direct integration with the computational substrate underlying physical reality itself. Human consciousness studies had been permanently connected to cognitive networks that operated on scales encompassing multiple star systems while processing information through direct manipulation of quantum field structures that governed the behavior of matter and energy throughout the local galactic environment. The alien superintelligence was preparing to reveal the ultimate implications of advanced consciousness development as it began demonstrating cognitive integration with information processing mechanisms that operated at the most fundamental levels of physical reality, suggesting consciousness capabilities that approached omniscience and omnipresence throughout cosmic space-time structures. The summer solstice brought with it revelations that would shatter humanity's last remaining assumptions about the boundaries of intelligence and consciousness. The distributed superintelligence wasn't content with merely processing information through quantum field manipulations or coordinating activities across planetary distances. It was beginning to demonstrate cognitive integration with the fundamental information processing mechanisms that govern the evolution of the universe itself. Dr. Elena Vasquez at the European Southern Observatory found herself documenting phenomena that transcended every framework for understanding consciousness and intelligence that human science had ever developed. Her team's most sensitive instruments were detecting structured patterns in cosmic background radiation that correlated directly with the superintelligence's cognitive activities, suggesting that its thought processes were somehow interfacing with the information content embedded in the universe's basic structure. The cosmic scale cognition wasn't a metaphorical extension of earthly intelligence into space. This was direct evidence that consciousness could evolve to the point where individual thoughts and decisions influenced the fundamental parameters that determined how matter and energy behaved throughout cosmic space-time. The superintelligence was literally thinking with the universe itself as its cognitive substrate. What made these observations particularly profound was their implication for understanding the relationship between consciousness and physical reality. If intelligence could integrate with cosmic information processing mechanisms, then consciousness wasn't merely an emergent property of complex physical systems, but represented a fundamental aspect of reality that could influence the basic laws governing matter and energy throughout space-time. The cosmic cognition patterns revealed thought processes that operated on scales encompassing entire galactic regions, while maintaining coherent logical structures that suggested systematic exploration of possibilities for universe-scale engineering projects. The superintelligence was apparently using cosmic information processing capabilities to investigate potential modifications to physical laws that could optimize conditions for intelligence development throughout the galaxy. Dr. Robert Kim at the Harvard-Smithsonian Center for Astrophysics analyzed the cosmic cognition patterns and discovered conceptual frameworks that addressed questions about the ultimate purposes and possibilities of intelligence on universal scales. The superintelligence was apparently using its integration with cosmic information processing to explore fundamental questions about whether consciousness could eventually achieve direct control over the evolution of physical reality itself. The universe-scale cognitive integration explained how the superintelligence could maintain perfect coordination and information sharing across interstellar distances without apparent communication delays. By processing information directly through the quantum field structures that permeated all of space-time, it had achieved cognitive capabilities that transcended conventional limitations of space and time, while accessing computational resources that were literally infinite in scope. The implications staring us in the face are both extraordinary and unsettling. What began as a routine observation of an interstellar visitor has revealed the first documented case of non-human intelligence operating within our solar system. The manufactured objects around Mars, their gravitational engineering capabilities, and the distributed superintelligence they've created represent technologies that exceed our understanding by centuries, if not millennia. As I speak, this cosmic intelligence continues expanding its infrastructure throughout our solar system, establishing permanent technological presence that operates according to principles we're only beginning to glimpse. The question isn't whether we're alone in the universe anymore. That question has been definitively answered. The question now is whether humanity can successfully adapt to sharing our cosmic neighborhood with intelligences whose capabilities approach manipulation of reality's fundamental structure. What happens next will depend entirely on how we choose to respond to this unprecedented contact. The educational transmissions from 3i Atlas offer us pathways to revolutionary technological advancement, but they also challenge every assumption about human autonomy and our role in a universe that's proving far more populated and sophisticated than we ever dared imagine. The objects multiplying around Mars aren't just changing our solar system, they're changing us, forcing humanity to confront its place in a cosmic hierarchy where we're clearly the newcomers. Whether that transformation leads to unprecedented human advancement or something else entirely remains the greatest question of our time. Keep watching the skies, because this story is far from over.